My name is Prasan, and I would like to talk about the Game Engine Architecture 3rd Edition book overview. So my chapters are from 1.1 to 1.4, and 1.1 is basically talks about the structure of a game team. So a game team is comprised of three main elements. So this can be the technical manager, or the technical team, the design team, and the art team. So these three teams are being managed by the project director. So the technical team basically works on the more technical aspect like coding and engine related things. The design, they basically look at visual side of things, visual and also how the game plays. And the art team basically focuses on more of the art side of things, like maybe texturing, lighting, not lighting, animations, things like that. Right, moving on. 1.2. So in the chapter 1.2, the author basically talks about or defines a game. So the author references a book called The Theory of Fun. And in that book, the author defines a game as a three-dimensional virtual world featuring a humanoid, animal, or vehicle as the main character under player control. Okay. So for the chapter 1.3, the author basically defines a game engine. So what is a game engine? Game engine is basically being featured or being defined as a framework or backbone of a game that contains elements of a game that doesn't really change across multiple games. So these can be things such as the lighting engine, the collision engine, or maybe not the collision, but the destruction engine, physics engine can be pre-baked into the engines. So what engines allow us to do is basically make multiple games on the same engine, where certain things don't really need to be coded from the beginning. Okay, so moving on. So 1.4. So in 1.3 we looked at how engines can help in making more games, but with less work. So in this chapter we're basically talking about how for certain genre of games, certain things in engines must be specific or must be specialized to allow for that game to be the best at what it does. So I'm just gonna go through a few examples here. So for example, the first person shooter genre basically looks at the player from a first person view, and it has to have certain like responsive camera and aiming mechanics for the player to feel good when they're aiming around, because usually these kind of games they need the player to be aiming around and looking in different directions in a fast manner. Okay, so I'm just going to skim through the other sections and you can pause and read on your own, because the time is not really allowing us to go through everything. Okay, thank you.
Hello and good day. I'm Chairman Choi, here to present my task one for game engine architecture. So first, I'll start with the player auto content. It's one of the genres of game which allows the player to build the content as part of the game. The fun of this type of genre of game is to enable the player to share with others, and simplicity will be the key for this type of game. Next will be the VR, AR, and MR. For virtual reality, is actually an immersive multimedia or computer simulated reality, which simulates the user presence in the real and imaginary world. Or for augmented reality and mixed reality, usually it presents the real world view and enhanced with the graphics. Usually requires the viewing device such as a phone. The game engine for virtual reality, actually the Unity and Unreal game engine supports the development for the virtual reality. And there are also one type of location-based entertainment which not include in VR, AR, or MR, which can seen in the Pokemon Go. Next will be other genres of game. The famous one will be like sports game, puzzle game, not electronic game, but have others like RPG, god games, social simulation games like Sim, and also the web-based game. So next will be the game engine survey. We have first the Quake family of engine, which create the Medal of Honor. Next will be the Unreal Engine, which have a rich and extensive feature set. Next will be the Half-Life Source engine, which create the Half-Life game and also the Portal. Next will be the Dice Frostbite games engine, which create the Battlefield. The Rockstar Advanced game engine, which create the GTA. The CryEngine, which created the game Far Cry, Sony Fury Engine, which creates numerous games for the Sony platform, Microsoft XNA Game Studio, which now is not exist, replaced by the Monogame, the Unity, which provides various platforms, and also other commercial game engine like Hero, Leapwork, and Tombstone Engine. We also have in-house like Sage, developed by EA, And the game engine that I mentioned just now, most of them started as the in-house engine. So we also have open source engine created by the amateur and professional game developer, and it's totally free, and the source code are freely available and have open development models like Augur and Panda 3D. Other than that, we also have 2D game engines for non-programmer, designed for them to build application for the Android and iPhone like Multimedia Fusion 2 and also Game Seller Creator. Lastly will be the runtime game architecture, which consists of a lot of layers. I'll just mention 6 of it. First will be the low-level components, which consists of the target hardware, the operating system, and also the device driver. Next will be the third-party system development kit and also the middleware, which consists of the data structure and algorithm, graphics, collision and physics, character animation, biomechanical character models, and also artificial intelligence. Next will be the platform independence layer, which allows the engine to be developed without the concern of the underlying platforms, and also it provides the wrapper. Next will be the core system, which have assertion, memory management, math library, and also the custom data structure and algorithm. It will be the resource manager, which provide the interface for accessing the assets and input data. Lastly will be one of the part for the rendering engine, which is the low-level renderer, which consists of the graphics device interface, material system, dynamic lighting system, and also lastly the text and font. That's all for my presentation. Thank you.
Assalamualaikum and very good day from Sharjah. My name is Mohammad Muntasir Billah, and in these presentations I'm going to discuss about game engine architectures. So basically in the game engine architectures I have assigned to two particular topic where I'm going to explain more detail in this topic, where the runtime engine architectures, as well as I'm going to discuss about the tools and the asset pipelines. So basically the runtime architectures, where the first thing we're going to look through is the scenes graph. So scenes graph is limits the number of primitives submitted for renderings. Also is used for fast terms calling to remove things outside of the visible screens, as well as is special subdivisions into BSP, quad-tree, octree, or k-tree, and it is usually optimize the callings, that is occlusions and PPS. Those are into occlusions and PPS, also the DVD LUD systems. So is visual effects. So visual effects is basically used to particle systems, used in particle systems, decal system, light mappings, dynamic shadows. Also is used to full screen post effects, and visual effects also define the manipulate the light mappings and dynamic shadows. Also HDR lightings is also work for PRT lighting, subsharp, scatter. Next, particular decal systems. After that, post effects, as well as environment mapping. Front end. So in the front end, usually have HUD menus, GUI for character manipulations, full motion video for cutscenes, and it's contain head-up display, full motion video, in-game cinematics, in-game GUI, in-game menus, also the direct mode. Profiling and debugging. So in the profiling and debugging is usually code timing, usually work for code timing, display, allowed to display stats on the screens, debug, dumping performance stats, decode and playback game events, print displacement outlook controls. So those are the effects usually debugged through the profile. Yeah. Then collision and physics. So basically the collisions educate body dynamics, and the physics, which is physics engines. So basically creation is the own unique undertaking. So those are many companies are use available libraries such as have physics, OG, Bullet. Yeah, those are companies use it in current. And there's the animations. So basically animation has 5 types of animations usually used for texture, body hierarchy, skeleton animations, part text animations, morphing. So, and the most popular animation is known as skeletal animations, which are usually work for input output layers, that is contain animation state, inverse kinematics, game-specific post-processing, LARP and adaptive blending, animation playback, sub-skeleton animation, and animation descriptions. His ID. So his ID and audio. So his ID basically the keyboard and mouse abstractions. It's joypads, it's specialized controllers. Those are his ID, human interface devices. And the audio is usually display face. Those are often overloaded until the ends, and also the varies in sophistication based on needs. And many games are existing tools such as Exact and Screams. So multiplayer network. So there has 4 main flavors of multiplayer networks, such as single screens, split screens multiplayer, network multiplayer, massive multiplayer online games. So single screens basically players on the same screens, and split screens multiplayer usually perspective on the same screens. Network multiplayer, which are the network together. Yeah, multiple compressed network work with the together, and massive multiplayer online games, which is basically run in a central server. Gameplay foundation systems are basically most everything that makes the game a game, and also is wall loadings, real-time aging simulations, static wall elements, and is also known as hierarchical objects. Event systems. So event system, object that need to communicate with one another. It's also easiest to handle those through a common systems, and it send the message that are routed to the event handler. Scripting systems, which allow for the creations on new game logic without recoupling, and also it speeds software developed considerably. Artificial intelligence foundations, which are proprietary AI building blocks, such as path plannings, nav mesh generations, object avoidance. Also, it has a middleware called GameWare that provides many of those features. So game-specific subsystems, which is specific stuff needed for a game, and each layer could be considerable outside of the game engine itself, such as weapons, power apps, vehicles, puzzles, and etc. So tools and asset pipeline. So tools and asset pipelines. So this is the architecture pipeline that usually use digital content creations in order to digital content creations. And easily you can see in the Maya and the DMax, they use this content. So then we have digital content creation. So as we see in the pipelines previously, so here we have a game engine deal with the data manifolds that has created on 3D meshes, textures, sound, animations, and also create using outside tools. Often create using outside tools. Those are Maya, 3D Max, Photoshop, and Sound Forge. Also, there has the tools that of course those are tools of course need to be easy and also the reliables related to content creations. And also there is asset conditioning pipelines. So basically it's produce a variety of file formats that are not optimized for game, and it usually store the data in an easy to read and platform specific format. For example, conditioning assets. So conditioning assets, which are 3D model that must be properly tessellated, and brass geometry, which are convex hulls with samples, skeleton animation data, audio data, particular system data. So those are conditioning assets under the asset tools. game world editors. So game world editors integrated into engines, and it allow game designer to work with the engines. For an example, using the real Unreal 8 Hammers and Radiance. Resource database. So need a way to store and manage the vast amounts of data. So in the reasons for that reason, some companies use relational databases, which is MySQLs or Oracles, and some companies use version control software such as Subversions, Purpose, or Git, and also there is some others use custom software, which is Notedog uses a custom GUI called Builder. And this is approach to two architectures where we have two categories, standalone and integrated. So standalone is another runtime engines, and integrated is runtime engines as well as tools and world builders. Web-based tools. So web-based tools basically there has various uses. The first uses you can see asset management. So there is asset management. For the asset management, we use the web-based tools. For the schedulings, we use web-based tools. Bug management. Also, the easier to build, usually easier to build than standalone applications. Also, it's easier to update without forcing any installs. If just need to present tabular data and have forms use a web interface. Yeah, that's all. That's pretty much it about the runtime architectures as well as the asset tools. There's tools and asset pipelines. Yeah, that's it from me. Thank you.
Good day, my name is Aaron Ryan Shemenka, and this is Tools of the Trade. Version control. What is version control? Version control allows multiple programmers or engineers to work on a group of files collectively. It is also known as source control because it contains the main source file. These are the examples of version controls. There are a lot of them, but the most famous one are Subversion and Git. So why do we use version controls? Well, it is very crucial because when developing a software of multiple engineers, you need version controls because it provides central repository. Second, it keeps history of changes made to each source file, and third is produce demos or make patches to older versions of the software. Okay, now we're going to compilers, linkers, and IDE. Compilers compile languages such as C++ and transform them from source code into an executable program. The most common compiler or linker is Visual Studio. However, Visual Studio it also acts as an integrated development environment. So, what are source files, headers, and translation units? In layman's term, source files is also translation units because the compiler that we talked just now translate one source file to a machine that to any language that the machine knows, like binary 0101s. Header files exist as distinct files from the point of view of the programmer, but it also sees as translation units. So what are libraries, executables, and dynamic link like libraries, DLL? Okay, when a translation unit is compiled, the resulting machine code is placed in an object file. These object files will then form together to become a library, which we can use to access the libraries, such as let's say we want to use this certain part of the code, we can just take it from that particular library. However, what is the difference with dynamic link libraries? Well, they'll also act as the previous mentioned, but it also can act as an executable, which can be used to run programs without being static. Okay, then build configurations. When you create a new project in Visual Studio, there will be two build configurations named debug and release. Debug is when you want to use a build for testing purposes, while release is for the final version of your program. And that is all for my recording. Thank you.
And good day. This is my topic, to log the trade and fundamental of software engineering for games. These are the topic inside. First, we are going to debugging tools, which have multiples. We have breakpoints, which is to stop a particular line to inspect what's happening. We have step through, where we are manually hit line by line after breakpoint is executed. We have call stack to show the function that is being called. We have watch window, where we are inspecting variable value. They have two types, simple data and complex data. And then we have data breakpoints, similar to breakpoints, but we are using memory address to hit the breakpoint instead. And then we have conditional breakpoint, where we are putting a condition so that when the condition is hit, breakpoint is hit. Then we have profiling tools, where we are using profiling tools to measure performance of our source code using Pareto principle, 80-20% rule, where 80% of the bug can be fixed by only 20% of the source code. The question is which 20% is to be optimized. And then here we have three types of profilers: statistical, instrumenting, and LOP. Statistical is unobtrusive and does not have any effect to our game. Instrumenting is the most accurate, but it makes the game slows down to unplayable state. And then we have LOP, which is launched by Microsoft, using statistical approach, but it analyzes stack instead. And then we have memory leak and corruption detection, where memory leak is memory is allocated but is never freed. And then we have memory corruption, where program writes to the wrong address inside the game. And then the popular tools for this part is usually Rational Purify, Insura++, and Valgrind. Here are some other tools. The first is difference. The tools are difference tool, three-way image tools, and hex editors. Difference tool is to compare two different versions of source code. Three-way image tool is to merge two sets of difference into one single final file. And then hex editors is to inspect and modify contents of binary file. Here are the C++ review and best practice. We have classes as an object, where class is a collection of data that is instantiated, which is known as object. Encapsulation to limit the interface to the user. And then we have inheritance, where there are class that inherits from a pre-existing class, known as parent-child relationship. We have polymorphism, where collection of object of different type to be manipulated through one single interface. Composition and aggregation, where we are grouping everything to execute high-level tasks, so individual class can become simpler. And then inside design pattern, we have three components: singleton, iterator, and abstract factory. C++ language standardization have been evolving, and they have undergone multiple version update. The goal is to make the language more powerful, to reduce ambiguity, and then to make the language easier to use. This is approached by refining the semantics, the meanings, and the rules of the language, add powerful feature, as well as removing unpopular or problematic features. Thank you.
Good day, Doctor. I'm Kosi, and I will explain about game engine architecture 3.1.2.1 until 3.3.1.4. The author discussed that the importance of a cautious approach to adopt new C++ language features. It emphasized that just because a feature exists, it doesn't mean that it should be immediately utilized. A conservative approach is necessary because leading-edge feature may not be fully supported by the compiler. There is a cost to switching between standards, and not every feature is universally acceptable. The author recommends adopting a new simple rule to use auto only in specific situations where it is necessary for clarity and readability. In summary, a judicious and carefully considered approach to adopting new language features will result in a stable corpus that is easy to understand, reason about, debug, and maintain. The author had also pointed some important things to achieve in coding convention, which include interface arcing, be consistent, and so on. Numeric representation. Numeric base. In programming language, 0p means binary and 0s means hexadecimal. For instance, 0p1101 means decimal 13. There are two techniques for representing signed and unsigned integers, sign and magnitude, and a more efficient technique called two complement. Fixed point notation constrains both the length of magnitudes and the amount of precision in the fractional part. Floating point notation was employed to overcome the constraint. The position of the decimal place is arbitrary and is specified with the help of an exponent. Thank you.
Good day, Prof, Doctor, and everyone. I am Chong Ling from Section 1. I will continue to present 3.3. In the primitive data types, there are portable size types. The F in front of the number represents floating point. The number represents the bit. The U and I represents unsigned and signed. The F behind of the number represents fast, which brings faster code. So besides, multi-byte values are the values that are larger than 8 bits, which is 1 by wide. It stores data in little endian, which in reverse order, or big endian, which in order as shown in the diagram. The data types also can be swept through integer endian swapping or floating point endian swapping. In the kilobytes versus kibibytes, we usually use kilobyte to represent 1000, but the computer programmer usually use kibibyte to represent 1024. Next, .cpp file is called as transaction units, which is the smallest unit of transaction. It generates an object file, and the linker combines all to resolve external reference. As you can see in the diagram, the reference in full.cpp are used in bar.cpp and vice versa. So for declaration versus definition, you can have multiple identical declarations in a .cpp file, but it can have only one definition in a .cpp file. Declaration has no linkage, but definition has linkage to cross-reference the entity, such as external linkage, which is visible to all .cpp file. The keyword is public, and internal linkage, which is seen in that .cpp file only, which the keyword is private. So the first memory layout is executable image. It's divided into segments or sections, which are text segment, BSS segment, data segment, and read-only data segment. The second one is program stack. This is the stack frame, which is block of memory. So B will be pushed on top of A and will be popped out before A. So the third one is dynamic allocation heap. Heap memory allocates memory dynamically. So new and delay operators are used to allocate and free the block of memory. So in the member variables, C-Struct or C++ class variables locates no memory, shown in the example. So later, it will be used in the function. So for the static keyword, it can be used in file or function scope, which is seen in that file only or function only. If it used in struct or class declaration, it is just like a global, but the visibility of the variables are controlled by private or protected or public, as shown in the diagram. That's all from me. Thank you.
Good day to everyone. My name is Li Wei Zhong, and now I would like to present about the object layout in memory. It is useful to visualize the memory layout of the classes and structures. For example, alignment and packing, and memory layout of C++ classes. Next, I would like to present on the computer hardware fundamentals. The simplest computer consists of the CPU and a bank of memory connected to one another on a motherboard via one or more buses and connected to external peripheral devices. CPU consists of arithmetic logic unit ALU, floating point unit FPU, vector processing unit VPU, memory controller MC, registers, and control unit CU. There are two types of memory, which are read-only memory ROM and random access memory RAM. Read-only memory retain their data even when power is not applied to them. Some types of read-only memory can be programmed only once. Electronically erasable programmable ROM, EEPROM, can be reprogrammed over and over again, such as flash drives, while random access memory consists of static RAM and dynamic RAM. Dynamic RAM needs to be refreshed periodically to prevent contents from disappearing. Both of these RAM retain their data as long as power is applied to them. Data is transferred between CPU and memory over connections known as buses. Bundle of parallel digital wires called lines, each of it represents a single bit of data. There are two types of buses, which are address bus and data bus. Address bus carries information about the memory location that the CPU wants to read from or write to, while data bus carries the actual data being transferred between the CPU and memory or input or output devices. So that's all from me. Thank you.
Good hello and good day, I am Chong Lei. First, what is assembly language and addressing mode? The assembly language is a low-level language that provides way for programmers to write low-level code using human-readable mnemonics to represent instructions and operands, whereas the addressing mode is an instruction that determines the data access and movements between the register and memory. Memory architecture typically involves two types of memory, the system memory, also called the RAM, and the graphics memory, also called VRAM. System memory is used to store the game code data and data access, while the graphics memory is used to store textual models and other graphical assets. Both types of memory can impact the game performance, so having enough of each is crucial for the smooth game experience. Virtual memory is a technique used by the operating system to extend the available memory beyond the physical RAM installed on a computer. It works by dividing a program memory into smaller blocks called pages. It provides several benefits but also has some drawbacks. Cache memory is more advanced type of memory that stores frequently accessed data or instructions closer to the processor than the RAM. It is an essential component in modern CPUs in order to help in reducing the time taken for the processor to access the data from the main memory. A CPU may contain three types of cache, the L1, L2, and L3. UMA is a traditional memory architecture where all processors and CPU have equal access to a shared physical memory pool. In UMA system, memory access time is the same regardless of the CPU location in the system. NUMA, on the other hand, is a more complex memory architecture that is used in larger systems when multiple CPUs are connected through a high-speed interconnect. It divides the memory into multiple memory banks, and the CPU is connected to one or more memory banks. The access time to the memory bank is dependent on the distance of the CPU to the memory bank. It's suitable in large-scale servers, supercomputers, and data centers. That's all about my presentation. Thank you.
Assalamualaikum and very good day. My name is Safia Karina Saplomo, and in this video, I would like to present the topic about parallelism and concurrent programming. So concurrency is a piece of software utilizes multiple flows of control to solve a problem that can also be implemented within a process using other techniques such as fiber or coroutines. So the central problem of concurrent programming is how to coordinate multiple reader and multiple writer of shared data. And then for parallelism, in computer field, the term parallelism refers to any situation which is two or more distinct hardware components are operating simultaneously. So in other words, parallel computer hardware can perform more than one task at a time. So for example, it's like Intel Core i7 and Ryzen 7. So implicit and explicit parallelism. Implicit parallelism are as known as instruction-level parallelism, is the use of parallelism computing hardware to improve the execution speed of a single thread. For example, like pipelining, superscalar architecture, very long instruction world architecture. And for explicit parallelism is referred to the use duplicated hardware components within a CPU, computer, or computer system to run more than one instruction stream simultaneously. For example, like multi-core CPUs, multiprocessor, and many more. And parallelism based on the kind of work being done divide into two categories, which is tasks and data. For task parallelism is when multiple heterogeneous operations are performed in parallel, and for data parallelism is when a single operation is performed on multiple data items in parallel. So the last slide is about the Flynn's taxonomy. So this is proposed by Michael G. Flynn from Stanford University. This approach breaks down the parallelism into a two-dimensional space. So this is another way to classify the varying degrees of parallelism well encountered in computer hardware. The space in this divided into 4 quadrants. We can see from the right there SISD, MIMD, SIMD, and the last one is MISD. That's all from me. Wassalamualaikum warahmatullahi wabarakatuh.
Hello, this is book review for Game Engine Architecture, page 225 to 247. My name is Ramadan Muhammad Jomantoro, and I will explain the topic above. So for the first is explicit parallelism. Explicit parallelism is a technique used in game engines to take advantage of multiple processing units to improve performance. Two common examples of explicit parallelism is hyper-threading and multi-core CPUs. The next is symmetric versus asymmetric multiprocessing. Symmetric and asymmetric multiprocessing, as well as distributed computing, allow game engines to distribute processing power across multiple machines to further improve performance. Symmetric multiprocessing involves multiple processors that share a single memory space, while asymmetric multiprocessing involves multiple processors that each have their own memory space. Distributed computing, on the other hand, involves multiple computers connected through a network. The next is operating system fundamentals. To develop efficient and robust game engines, it is essential to understand the fundamentals of operating system. These include the kernel, interrupts, kernel calls, primitive multitasking processes, and threads. The first is the kernel. The kernel is central component of the operating system that manages system research and provides service to application. It operates in two models, kernel mode and user mode. Kernel mode has higher privilege and access to system resource than user mode. The next is interrupts. Interrupts are signal sent by hardware, device, or software to CPU that temporarily halt the current program and switch to another program or process. The next is preventive multitasking. Preventive multitasking allows the operating system to switch between multiple processes or threads, giving the illusion of simultaneous execution. The next is process. A process is an instance of running a program. It is include memory, program code, resource, and used by the program. The next is a threads. A thread is lightweighted process that can run concurrently with other threads. Multiple threads can be run with a single process, allowing for the parallel execution of tasks. The threads have thread libraries. Thread libraries provide an abstraction layer for creating and managing threads. They are used to simplify the process of creating and managing threads. The next is thread creation and termination. Threads can be created and terminated by dynamically at runtime. The operating system provides API for creating and managing threads. The next is joining threads. Joining threads allow one thread to wait for another thread to complete before continuing execution. The next is polling, blocking, and yielding. The thread synchronization techniques such as polling, blocking, and yielding are used to manage access to shared resource driven to rest condition. The next is wrap up the presentation. In conclusion, understanding operating system fundamentals is crucial for developing efficient and robust game engines. Techniques such as explicit parallelism and multiprocessing allow game engines to take advantage of multiple processing units and improve performance. The kernel interrupts, kernel calls, preventive multitasking process, and threads are essential component of operating system that must be understood for effective game engine development. Thank you for listening for this presentation on operating system fundamentals in game engine architecture. Thank you. Have a good day.
Assalamualaikum and hi, I'm Nurana Najwa and this is my game engine architecture reading slide. Sequences and gesture detection. Here we have the definition of gesture detection and the difference between action detected and if action is not detected. The first one is the rapid button tapping, which is focused on the frequency of button presses determines the validity of the gesture. Next one, we have multi-button sequence, which is the code detects a sequence of button presses such as A, B, A within 1 second. The last example for the gesture detection is thumbstick rotation, so which means that the codes detect when the player is rotating the left thumbstick in a clockwise circle. In multiplayer games, multiple HDI can be either plug operated or battery operated. So these are the differences between plug operated and battery operated. Cross-platform game engines need to handle HDI inputs and outputs in a way that works on different platforms. So these are the two which is that can be implemented into the HDI inputs and outputs, which is abstract button and axis IDs, and name abstract controls based on their function. In games, players often have options for customizing controls, so function in a game can have unique ID or table maps. In some games, one physical control can have different functions depending on the context. It can either state machines or control ownership. In Chapter 10, we will explore the common development of debugging tools found in professional game engines. Debugging tools such as breakpoints and watch windows may not be always effective, so many game engines use print statement for debugging purpose. So on the logging and tracing, we have printf function. Here are the two functions for the output debug string, which is the first one is debug printf that takes a variable line argument list, and the next one is vdebug printf that takes a list argument so that the programmers can build additional printing functions in terms of vdebug printf. Next, we have verbosity. So verbosity is needed to control the amount of printed output. Game engines typically have a mechanism for setting the verbosity level at runtime, with higher levels producing more print statements. So one of the company, which is the Naughty Dog developers, use Connector. So Connector is a web-based interface to access debugging information from the game engine while it's running. So the channels of information are collected by Redis, which is a lightweight value store. So the Connector interface enables the user to view the debugging information from the game engine itself. Plus, the game engine can output debug stacks into different channels, each linked to a specific animations. We have been known that matte is an extension in the modern interactive games that are used for the movement or collision detection. Plus, debug drawing is a feature in a game engines that provides an API for drawing. So debug drawing can save time by making logical and mathematical errors obvious. Continue about the debug drawing API. A debug drawing API must fulfill these requirements, such as that the debug drawing API need to be easy to use and include primitives such as line, spheres, points. Besides that, it should allow for drawing in either world space or screen space. Plus, the API should be callable from anywhere in the code. And it also capable of handling a large number of debug primitives.
Hi, I'm Lim Junqing. Today I'll be presenting about a few topics covered in the game engine architecture. There are 5 trait synchronization primitives, the mutexes, critical sections, condition variables, semaphores, and Windows events. So to implement the mutexes, we can use the POSIX trait library, C++ standard library, and Windows. And these libraries will provide functions for creating and manipulating the threads. Let's move to the critical sections. A critical section is a block that accesses shared resource in a multi-threaded program. So when a thread tries to enter a critical section that's already locked by another thread, it will use a spin lock to wait until the other thread is done. A condition variable will consist of a queue of threads and is like a flag that allows a thread to check if a specific event has occurred. If the event hasn't happened yet, the thread can block itself and wait for the event to occur. So the two main operations will be wait and notify. While for the semaphores, a semaphore is essentially a counter that is used to control access to shared resource. It has also the two main operations, the wait and signal. The wait will decrement the counter and blocks the calling thread if the counter becomes 0. So in the Windows events, a mechanism called an event object will be used. Until now, we have went through all the 5 trait synchronization primitives, and we can see that most of them have similar characteristics in which their main operations would be putting a thread to sleep and wake up the thread. However, the effectiveness of the implementations would depend on the concurrency patterns. Next, we move to the problems with the lock-based currency. So for the deadlock, the system will become unresponsive because no thread in the system can make progress. And to achieve a deadlock, we need to fulfill the Kaufman conditions, the mutual exclusion, hold and wait, no lock preemption, and circular wait. While for the live lock, it is similar to a deadlock, but the difference is the processes involved are still actively running and consuming resources. While for the starvation, it occurs when a higher priority thread or process continually acquires the lock on a shared resource, preventing lower priority threads from accessing it. While for the priority inversion, it happens when a high priority thread is blocked by a lower priority thread that is currently holding a lock on a shared resource. The dining philosophers will involve a group of philosophers who share a circular table and ultimately alternate between thinking and eating. These problems will lead to a system performance degradation and also reduce in the throughput. So let's move to the rules of thumb for concurrency. So for the global ordering rules, the main idea is to maintain a consistent ordering of events across all threads to ensure that the system behaves accurately, while for the transaction-based algorithms, it allows multiple operations to be executed as a single atomic transaction. The goal of the minimizing contention is to reduce the likelihood of conflicts or collisions between the threads. And lastly, the trade safety, ensuring that resources are accessed and updated in a way that does not cause conflicts or consistency. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. This is Mohammed Zaini, and this is my presentation from block-free concurrency to SIMD. So to start with, we have acquire and release cymatics. As explained before, fences guarantee us the priority of read and writes. So we have three types, which is release cymatics, acquire cymatics, and full fence cymatics. The release cymatics ensure that the write doesn't get passed by read or write that comes before it. Acquires the same but for read and reverse the direction. Full fence, it opens the program for the whole memory and it's bidirectional. For CPU memory models, modern CPUs have stronger memory which have built-in cymatics by default in them. Atomic variables, which is a class template that allows C++ to provide us with nothing or all type of process or a lock that closes or encrypts type of data or gives the priority to a certain process. There is a memory order for C++, which is relaxed, which is an atomic process: consume, release, acquire, and acquire release. Concurrency in interrupted programming language like Java and C++, since they use virtual machines to a certain point, they're volatile type qualifiers, which will be hard to optimize, and they cannot be interrupted by any other thread compared to C++, which will have built-in automatic operations implemented in their kernels and compiler. We have type of locks to lock the process in place. The simplest one is spin lock, which is a low synchronization mechanism suitable for usage on shared memory multiprocessor. We have scope lock, which locks when the process leaves. We have printrend locks, which sets IDs to a process, and if it's on, it will pass the other and lock it for itself. We have reader writer, which will have multiple readers and one writer that edits and locks the lock. Locks not needed assertion, which uses Boolean functions, and lock free transaction. Which cause stress which avoid stress to be sleeping or get stuck in a busy wait loop. So this is the end of the chapter. Beginning of the new model, which is SIMD, single interaction multiple data, which is a form of parallelism where modern multiprocessors can perform a mathematical operation on multiple data in parallel using single machine interaction. And for the last slide, SSE interaction set. We'll discuss single instruction multiple data and the parallelism and how it works in modern process.
Assalamualaikum and good day, Prof. My name is Rada binti Abdul Rahman. I would like to do a book review on game engine architecture on chapter 4.10.1.1 until 4.11.3. Okay, so first regarding the SSE, the streaming SIMD extension. So the SSE instruction set and register can be used to optimize game engine code. So it's provide a set of 1 to 8 bit register which can hold 4 to bits of floating points. So the SSE instruction can perform using 3. So first is vectorize.product, vector matrix multiplication, and matrix multiplication. And then next, the general vectorization also can be used to optimize loop that operate on arrays of data. So it suggests that when writing the optimized code, we need to check the compiler based on what we want to do. Next, the vector prediction also can be used to execute code based on the values of vector, which is it can improve the performance of code. And then the SSE instruction also can improve the performance of the code for the performance of the game, but we need to have a careful programming to ensure the correctness and the maintainability. Lastly, the introduction to GPU programming. So first is about the data parallel computation that perform the same computation on different pieces of data in parallel. So GPU are well suited for data parallel computation due to the architecture. So it has two techniques of game engine, which is the batching and threading. So it is to maximize their parallelism of their computation and achieve high performance. Second is about the compute kernels. So it is small and highly optimized function design to run on GPU or other parallel processing hardware. So it used for physics simulations, for AI, and post-processing effect. So to manage a compute kernels and maximize performance, we use the task dispatching game engine. We use the game engine and use this task dispatching. So to write efficient compute kernels, the developers need to know their hardware that they are targeting and the specific requirement of the task. Okay, third is about the executing kernels. So execute kernels involve launching a compute kernel on a GPU or other parallel processing hardware. So threads can be used to organize into the thread blocks or work groups. So the kernel also can be launched asynchronously and optimized for performance. So memory synchronization and error checking are important during the executing kernels. And then the game engine uses libraries such as CUDA to handle the details of launching and execute kernels. So lastly, for the data parallel computation and compute kernels are essential tools to achieve a high level of performance in game engine.
Assalamualaikum warahmatullahi wabarakatuh. My name is Samara Wariafdila and my matrix number is A1 and EC220. So for this video, I will do a video about book review game engine architecture subtopic take 4.11.4 until 5.3. First one, GPU threads and thread groups. GPU threads and thread groups are concepts related to parallel processing on a GPU. A GPU is designed to perform many calculations simultaneously, and thread group are a collection of threads that work together to accomplish a specific task. In order to take advantage of the parallel processing power of a GPU, developers write programs that are executed by many small independent threads. A typical GPU is comprised of multiple compute units, each of which acts like a stripped-down CPU core. A CU contains an instruction of fetch and L1 charge, possibly a block of local data storage RAM. And GPU architecture have evolved over time to improve performance and efficiency. One such evolution is the transition from SIMD to SIMT. And then this is the concept of from SIMD to SIMT. Whenever one of wavefront stalls, for example, due to memory access latency, the SIMD unit context switch to another wavefront to fill the delay slot. And the next one is 3D math for games, solving 3D problem in 2D. And then this is the point and vectors, the example of Cartesian coordinates, cylinder coordinates, spherical coordinates, and left-handed and right-handed. Vectors is a quantity that has both magnitude and direction in n-dimensional space, and a vector can be used to represent a point provided that we fix the tail of the vector to the origin of our coordinate system. Cartesian basis vectors use 2 or 3 mutually perpendicular axes to specify a position in 2D or 3D space. And then this is the example of vector operation. And these normal vectors and dot product and projection. The formula are displayed in the slides. And this is the sum common dot product test. And this is the formula of cross product. And the properties of the cross product are the cross product is not commutative. And this is the formula of the cross product is not commutative, anti-commutative, distributive, combined with scalar multiplication, and Cartesian basic vectors are related by cross product as follows, as displayed in the slide. And then the next one is linear interpolation of points and vector. And linear interpolation is a simple mathematical, and where beta range from 0 to 1 inclusive, and the formula is as displayed here. And this is the matrix. And I think that's all about the book review. Thank you. Wassalamualaikum.
Good day and hi doctor. My name is Jin from section 2. Now I'm going to present the book review of Game Engine Architecture. My reading part is from chapter 5.3 Matrices to 5.4 Containers. A matrix is an arrangement of number in rows and columns with m rows and n columns. Matrices are useful for representing linear transformations such as scaling, rotation, and translation. Metric multiplication is a common operation in linear algebra. It's worth noting that the word inverse of a series of concatenated matrices can be expressed as the reverse order of the inverse of each matrix. An affine transformation matrix can be constructed by concatenating a sequence of 4 times 4 matrices that represent pure translation, rotation, and scale. In physics, a group of axes that represent a frame of reference is known as a coordinate frame, while in the game industry, this is also called a coordinate space or just space. There are 3 types of coordinate spaces, such as model space, world space, and real space. In gaming and computer graphics, changing an object position, orientation, and scale from one coordinate system to another is known as a change of basis and is frequently employed. There are 4 parts in change of basis, such as coordinate space hierarchy, building a change of basic matrix, extracting unit basic vector from a matrix, and transforming coordinate system versus vector. A normal vector is a unique type of vector that not only has a unit length but must also remain perpendicularly to the associated surface or plane. Therefore, extra extension is required when converting a normal vector to maintain its length and perpendicularity properties. We have 2 choices when storing a matrix in a 2-dimensional C or C++ array, which are store the vectors contiguously in memory and store the vectors directly in memory. Next, using a 3 times 3 matrix to represent a rotation in 3D is not always ideal due to the excessive amount of value needed to represent a rotation. A quaternion is a mathematical object that overcomes the problem of using a metric to represent a rotation, and it looks like a 4-dimensional vector but behaves differently. Quaternions can do things like measuring size and combining vectors, similar to what vector algebra does. In game engine quaternion, sums won't be seen unless they are scaled to maintain the unit length requirement. So that's all for my book review. Thank you.
Good day, Doctor. My name is Gojo Yi, and my metric number is A19EC0047. Today, I would like to present the book review for Game Engine Architecture from subtopic 5.4 to 6.1. From 5.4 quaternions, it is a scalar term with 3 imaginary terms involving I, j, and also k. So a vector can be written in quaternion form by setting its scalar to zeros. So the concatenating quaternion-based transformation involves the multiplying the quaternion in opposite order of applying the rotation. So quaternion multiplication formula can be found in this topic, and it transforms the model space vector into a world space equivalent in game. So for the next one is a comparison of the rotational representation. So irregular angle is simple, however it suffers from the gimbal lock and interpolation difficulties. For the 3 times 3 matrix, it is effective, however it also not particularly intuitive and suffer from the interpolation and take out a lot of space. For the SRT, it combines a quaternion and a translation vector with a scales vectors to represent affine transformations, and is smaller and easily to interpolate compared to the matrix. For the D or F is a number of independent ways of object physically can change, and also it suffers some constraint because we need to maintain 3 degrees of freedom. For the axis plus angles, it defines the axis of rotation and angle of rotation as scalar, so it also cannot be easily interpolated and applied to the point and vectors straightforwardly. So for the quaternion used for concatenating and applying the rotation directly to the point and vectors, it is easily to interpreted and small size. For the dual quaternion, is rigid transformation offer benefit of interpolation rendering involving 3 or more transforms. So for the other useful mathematical object involve the line, ray, and also line segment. So the ray can be a line that extends to the infinity with only one direction. So a plane can be represented by a point with a unique vector normal to the plane. So for the random number generator, so you can produce the pseudo random values. And also the linear conjunction generator are fast, however it will produce a low quality sequence. So for the Manson twistor, improve the issue of the colossal period and high order dimension equidistribution. However, it also find out that SOR shift keys 99 and mother of all generators are simple and faster compared to the Manson twistor. So for the topic 6, it involves the 6x1 subsystem and start up and start down. So game engine need low level of support system. So C++ have unpredictable orders, so single solutions are often used, but it doesn't work with C++ native startup and startup semantics. Solution provider is the function with static variables. We define the explicit startup and shutdown function to control the global singleton construction order and allow each class member's manager to be called in required orders. I think that's all until 6.1, and thank you.
Hi, my name is Ng Jing I'll continue with Chapter 6, Engine Support Systems. First is about the subsystem startup and shutdown. So a game engine comprises multiple interacting subsystems that need to be configured and initialized in a specific order upon startup. So the subsystem interdependencies determine their starting order, with the shutdown typically happening in the reverse order. So in this chapter, we discuss the low-level support systems that needed for the game engine, including the subsystem startup and shutdown. The first is about the C++ programming language native startup and shutdown semantic cannot be leveraged to initialize, and the shutdown system is in an unpredictable order. So to handle this, the static variable declared within the function will not be constructed before the main function is called, but rather on the first invocation of that function. So this will help to allow for controlling order of the constructions for global singleton. Besides, the brute force approach of defining the explicit startup and shutdown functions for each singleton manager class is suggested as a very simple and easy to implement debug method to start up and shut down subsystems. And next is about the example that given in this chapter, the Augur real engines. So the Augur uses of the templated Augur singleton base class to avoid the deferred construction issues by creating and destroying the singleton explicitly in a predetermined order through the Augur root class function. Next is about the memory management. So there are a few ways that will affect the memory performance, including slow dynamic memory allocations. And the dynamic memory allocations can be very expensive due to the cost of context switching. Next is the inefficient memory access patterns. So how can we optimize the memory utilization? First is by avoiding the dynamic allocations. So we can keeping the heap allocations to a minimum and implementing the custom allocators. So there are two common types of custom allocators used. There are the stack allocators and pool allocators. And there are also other subtopics that discussed in this chapter, which is about the dynamic heap allocations can lead to memory fragmentations, which will cause the allocation values even if there are enough free memory access. So besides, using the stack and pool allocators can help to prevent the memory fragmentations. And next, the smart pointer or the handles can be used to address the issue of pointer relocations during the defragmentation of heap. There are various collection-oriented of data structures or containers helps to manage the data elements. So this includes the array, dynamic array, linked lists, stack, queues and trees, heaps, dictionaries, sets, and graphs. So that's all for my part. Thank you.
Good day, everyone. My name is Mokashan, and I'm now going to talk about the container operation. So the game engine that makes use of the container classes uses various operations. For example, is insert, remove, iteration, find, random access, and also for sort. Next, dynamic arrays and chunky allocation. So dynamic arrays is used if the size of an array cannot be determined initially. So it allocates an element buffer initially and then grow the list only if needed afterwards. So this is to make sure that there is no memory extra usage. All right. So dictionary and hash tables is the table of key value pairs. So for this key value pairs actually existing collision, which two or more keys end up occupying the same slot in the hash table. So this dictionary is using the hashing method, which is process of turning a key of some data type into an integer. So the two figure below shows that how to handling for this collision. So for open hash table, it use linked list table to avoid collision, while for this closed hash table is actually prompt to find the new slot. All right. So strings is actually almost existing in every game project. So however, there is some small problem while using the strings, which is limitation of on the sites and also the localization. So and also while using the string, we need to use the classes, which is import the library of std string. So if not, the programmer might need to use the array of characters. All right, next. Unique identifiers. So unique identifier is used to keep track the name of the object. So string is actually the best choices, while the speed between the unique identifier, which is string, is compared using the strcmp, which is quite slow. And the best method is using the hash string, which means that we hash our strings and also so that it can be compared just like any other integers, which is quite faster. All right. Localization. So localization of a game is actually a big undertaking. So is to make sure that every user can use different type of languages in the game. And so why using Unicode? So Unicode is actually exists because of the limitation of ANSI standard. So the unique hexadecimal code is actually the special of the Unicode. So it might need to use the select encoding method, which is using the UTF-8 and UTF-16 to exist. All right, I think that's all for my presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin Johar. In this video, I would like to present the review of the book named Game Engine Architecture by Jason Gregory. So for the chapter 30.5.3, it will explain the example of uses of collision and physics in the game. But I will explain another 4 use example, which is destructible object, character mechanics, camera collision, and rectal integration. So for the chapter 30.6, it explains the advanced physics feature. There are 7 physics feature, which is deformable body, cloth, hair, water surface simulation and buoyancy, physically generated audiosynthesis, general fluid dynamic simulation, physically based audiosynthesis, and general purpose GPU. So we will go to the chapter 14, which is audio. So the graphic engine is charged with the task of reproducing as accurately and believably as possible what the player will actually hear. Meanwhile, the audio engine is charged with the task of reproducing as accurately and believably as possible what the player would actually hear. So for the chapter 40.1, which is the physics of sounds. So sounds is a compression wave that travel through air, and sound also is a dynamic phenomenon. The sound pressure varies over time. So there is a property of the sound wave. The sound wave consists of the repeating pattern characteristic to instrument. So in the chapter 40.1.2, they explain the loudness of the decibel. In order to manage wide dynamic range of sound pressure variation, we measure sound intensity and the unit decibel. So for the sound wave propagation, the developer usually model the absorption and reflection in our virtual sound wave. There are actually 5 model of absorption and reflection, which is fall off the distance, atmospheric absorption, phase shift and interference, which is a multiple wave interaction, reverb and echo, and lastly the Doppler effect. So in the chapter 40.1.4, which is perception and position, explain the human auditory system that involve to allow a reasonably accurate perception of the position of sound in the space around us. So they actually the 4 element in that affect the position of sound, which will fall off the distance, atmospheric absorption, having a ears, and the ear shape. I think that's for my part in the review of the game engine architecture. Thank you.
Assalamualaikum and good day. My name is Nur Syafiqah binti Abdul Halim. In this video, I would like to summarize what I have read from a book named Game Engine Architecture, third edition by Jason Gregory. So this is the topic that I have covered from this book. Move to the first one is the priorities. When a game is running, file I/O is a system that has deadline just like everything else, have different priorities, and the higher priority I/O also request. Okay, we move to how asynchronous I/O works. Asynchronous file I/O is a separate thread to handle requests, notify the main thread when they are done. Moving code to a separate thread or processor can make synchronous operation asynchronous. Okay, next we move to offline resources management and the tool chain. The first one is the dealing with data size. Naughty Dogs build their own tools that use symbolic links. They also requires the team to build their own version control system from scratch, and it currently works on UNIX, not for Windows. Okay, then a good resource management system should handle different resources, do basic operation, move files, maintain referential integrity and reference history, and also allow searching and questioning in various ways. And then we move to some successful resource database design. Here we have Unreal Engine 4, Naughty Dogs, Microsoft XNA, and also Augur Resource Management. And then we go to the asset conditioning pipeline. It must have exporters, resource compilers, and also resources linkers. So resource dependencies and build rules can change into a format that the game engine can use. And we move to a resource management system should have keep one copy of each unit resources, manage resource lifetime, load and unload, handle composite resource, maintain integrity between resources, use memory efficiently, allow custom processing of resources, provide a single interface, and also handling streaming of resources. Okay, sometimes a single file format can be used to house many different types of asset in single format. For example, the Granny SDK implemented flexible open file format to store the three things right here. Okay, memory management for resources have 5. The first one is heap-based resource allocation, pool-based resource allocation, state-based resources allocation, resource chunk allocators, and also section resource file. Okay, a game resource database is made up of files that depend on each other. Composite resources such as 3D model groups are groups of independent files that must be loaded together. So that's all from my video. Thank you very much.
My name is Yukawi. Here I would like to share about the textbook review, which is the game engine architecture from the chapter 7.2.2 until the chapter 8.5.2. So first is the runtime resource management. The number 9 is the handling cross-reference between resource. Externally, reference objects have to be handled differently. Store the path along with the globally unique identifiers or objects. Log each file first, then fix the reference in the second pass. The next is a post-loss initializations. Cannot always load in the ready-to-go state. Is unavailable. Need to move the test data to the video cards. And then the next is the available but not convenient. Calculating string data during the development. Init and destroy may be the simplest strategy. Next, 8.1 rendering loop. Programmer optimize render using the specialization hardware. SO operations and copy a collection of backgrounds. Look at the disk code. When it's not great, you always to update the camera, update the skins elements, render scene and the space buffer. Next is the game load. The game load is one example. Simple example is the pawns. It starts as the tennis of 2 in 1958. So here is the code for the pawns. The next is the game log architecture stars. They have the 3, which is the window message funds, callback driver frameworks, and the event-based updating. So for the window message funds, the message that we sentence, everything else will be paused. Next is the callback driver frameworks. Developer built a class that implement a friends listener that called before and after the things is rendered. And then for the event-based updatings, it's more like the friends listener but use an event bus for the components to speak with one another. The next is the 8.4 express timeline. They have 3 also, which is the real-time, scan times, and local and global times. Real-time is measured by the CPU high resolution timers. For the game times, its animation have their own timeline. We can make it to global time into anywhere we want. And then local and global times is mostly controlled by real time but can be paused, slow and speed up. Next is the measure and dealing with time. The first is the frame rate and time delta. Use delta time to update the motion of object in the game to keep the precision time of content despite the frame rate. The next is the from frame rate to speed. There are 5 methods, which is the old school CPU distributed gains, updating based on less sky. Use a running average. governance, the flank right, screen tearing, and V-signs. That's all for me. Thank you.
Assalamualaikum. My name is Aina Zira binti Azharuddin. So I will continue to explain chapter 8.5 countries. So all modern CPU contain a high resolution timer. Different microprocessor OS provide different ways to query the high resolution timer. A CPU high resolution timer register is 64 bits to ensure that it will not wrap too often, and timing measurement taken via high resolution timer can be inaccurate in certain circumstances. There are two choices to make before measuring the time duration, which are what time unit should be used and what data type should be used to start time measurement. So, how to dealing with breakpoints is we can assume that we have just resumed execution after breakpoints, and we can set the delta time artificially. Next is 8.6 is multiprocessor game loops. So task decomposition is to decompose the various tasks that are performed during each iteration of our game loop into multiple subtasks. It also can transform our software from a sequential program to a concurrent one. And there are two categories of task decomposition, which are task parallelism and data parallelism. Here is the one thread per subsystem. And what is scatter and gather? Scatter is a unit of where is divided into smaller subunits, distributed into multiple processing cores for execution, and gather is the result combined or finalized in an appropriate manner once all workloads have been completed. This is the example of scatter and gather in the game loop. One or more scatter-gather operation might be performed at various times during one iteration of the game loop by the master game loop thread. And SIMD for scatter and gather. So loop vectorization as a means of leveraging SIMD parallelism to improve the performance of data-intensive work. So how to make scatter and gather more efficient is using a pool of pre-spawn thread. 8.6.4 is job system, which is general purpose system for executing the arbitrary units of work. So this is example of the job system, which is work is broken down into fine-grained chunks that can be picked up by any available processor, and it can help maximize processor utilization while providing the main game loop with improved flexibility. This is example of simple job system based on the thread pool. And what is the limitation of thread-based job is each running job share the same call stack, and how to overcome the problem is we can divide job as coroutine and job as fibers. Next is how to implement job counters. We can associate a handle with each job just as thread have handles in most thread libraries. Job synchronous primitive is a threading library provide a set of thread synchronization primitive. Alright, next the implementation depending on how the job system is actually implemented, and we can use spin lock instead of OS mutexes. And the Naughty Dog system use spin locks for most of its looking needs and offers a visualization view. Example of job system can find in PS4. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin Muhammad Nuji. I will present the book review for chapter 9, which is Human Interface Devices or HID. So HID is to investigate how game engines read, process, and utilize the input from HID, and how output from device provide feedback from the human player. So we go to the first subtopic. There's a lot of human interface devices such as consoles, Wii remote, joystick controller, steering wheel controller, and also include mouse and also keyboard. Next, we go to 9.2, interfacing with a HID. First, we have polling. Polling is to measure how often a device report its position back to the computer. The second one is interrupts. Interrupt is an electronic signal generated by the hardware, which is CPU, temporarily suspend execution of the main program. Last one is wireless devices. As you know, wireless devices will usually use Bluetooth to connect the controller to the computer. Next subtopic is types of inputs. First one is digital buttons. As you know, there's two stages, which is press or not be pressed. For example, if the player press 0, it will go up, and if the player press 1, it will go down. The second one is analog axis and buttons. So analog is the range of value is more than 0 than 1, and usually there's two axes, which is axis X and axis Y. The third one is a relative axis. Relative axis, there's no clear location of which input value should be 0. And for example, again, is Mario and also trackballs. So the fourth one is accelerometers. Accelerometers is usually a joystick and also the Wiimote. So it detects the acceleration along three principles, which is X, Y, and Z. For 3D orientation with the Wiimote Auto Shock, it's the same as accelerometers, but in 3D version, same in axis X, Y, and Z. The last one is cameras. Cameras is act as a sensor and usually used for gamers to stream their game in YouTube or in Facebook. So We go to the 9.4, which is types of outputs. There's three of type of output, which is rumble, force, feedback, and also audio. For rumble, rumble is a vibration while playing the games. For example, if the player hits some object, it can feel the vibration at the controller. The second one is force feedback. Force feedback is a technique to assist the motion of humans. And lastly is audio. Audio is the sound produced from the controller of the low quality speaker at the controller. So we go to the last subtopic, which is 9.5, game engines HID system. The first one is dead zone. Dead zone must be wide enough to account the noises input generated by the undisturbed control. The second one is analog signal filtering, is to filter the raw inputs coming from HID. And last one is presenting input events. The first one is button up and button down, as before, up for 0 and down for 1. And lastly is chords. Chords is a group of buttons pressed at the same time. It will produce a unique behavior in the game, such as if the player want to run while jumping, so they will press J button and also the right click button to run. So that's all from me. Thank you very much.
Assalamualaikum and hi, I'm Nurana Najwa and this is my game engine architecture reading slide. Sequences and gesture detection. Here we have the definition of gesture detection and the difference between action detected and if action is not detected. The first one is the rapid button tapping, which is focused on the frequency of button presses determines the validity of the gesture. Next one, we have multi-button sequence, which is the code detects a sequence of button presses such as A, B, A within 1 second. The last example for the gesture detection is thumbstick rotation, so which means that the codes detect when the player is rotating the left thumbstick in a clockwise circle. In multiplayer games, multiple HDI can be either plug operated or battery operated. So these are the differences between plug operated and battery operated. Cross-platform game engines need to handle HDI inputs and outputs in a way that works on different platforms. So these are the two which is that can be implemented into the HDI inputs and outputs, which is abstract button and axis IDs, and name abstract controls based on their functions. In games, players often have options for customizing controls, so function in a game can have unique ID or table maps. In some games, one physical control can have different functions depending on the context. It can either state machines or control ownership. In Chapter 10, we will explore the common development of debugging tools found in professional game engines. Debugging tools such as breakpoints and watch windows may not be always effective, so many game engines use print statement for debugging purpose. So under logging and tracing, we have printf function. Here are the two functions for the output debug string, which is the first one is debug printf that takes a variable length argument list, and the next one is vdebug printf that takes a list argument so that the programmers can build additional printing functions in terms of vdebug printf. Next, we have verbosity. So verbosity is needed to control the amount of printed output. Game engines typically have a mechanism for setting the verbosity level at runtime, with higher levels producing more print statements. So one of the company, which is the Naughty Dog developers, use Connector. So Connector is a web-based interface to access debugging information from the game engine while it's running. So the channels of information are collected by Redis, which is a lightweight value store. So the Connector interface enables the user to view the debugging information from the game engine itself. Plus, the game engine can output debug stacks into different channels, each linked to a specific animations. We have been known that matte is an extension in the modern interactive games that are used for the movement or collision detection. Plus, debug drawing is a feature in a game engines that provides an API for drawing. So debug drawing can save time by making logical and mathematical errors obvious. Continue about the debug drawing API. A debug drawing API must fulfill these requirements, such as that the debug drawing API need to be easy to use and include primitives such as line, spheres, points. Besides that, it should allow for drawing in either world space or screen space. Plus, the API should be callable from anywhere in the code. And it also capable of handling a large number of debug primitives.
Good day, everyone. My name is Kyusui Ki. I will briefly talk about the debug drawing facilities. Here is the overview of the topic I cover. So let's start with the debug drawing API. It is intended for visualization during development and debugging. A debug drawing API can save huge amount of time for developer to figure out some bugs while developing the game. Therefore, it is simple and easy to use and support a useful set of primitives such as lines, spheres, and text. Next, in-game menus allows the developers, programmers, and game designers to configure some settings such as rendering, animation, audio, and AI without change the source code, recompile, and rerun the game. This greatly saves the amount of time the game development team spends on debugging and setting out new levels of game mechanics.
Besides, we also have in-game console. It is an addition to in-game menu. It provides command line interaction to the game engine features. Therefore, the developer can build and manipulate global engine settings as well as running arbitrary commands. Next, we also need other crucial features to accompany the in-game menu or console system, which are the first one, detach camera from the player character and fly around the game, and the second one, the ability to pause and unpause the game. So here are some example pictures for debug drawing API, in-game menus, and in-game console. So in debug drawing API, the lines and circle heads support the developers to know where the position of the player is. And here's the console that enables the developers to use some command. And in-game menu, the developer can choose the menu simply from here without changing the code behind. Apart from that, the developer also needs cheats to break the rules of the game, so it is helpful for testing out gameplay without having to repeat the state every time. For example, they can place a player character in any way they want to test the scene. We also need the ability to capture screenshots and write them to disks in image format. Many game engines also provide in-profiling tool that permits the programmer to annotate blocks of code that should be timed and give them human-readable names. Last but not least, in-game memory stats and leak detection. Since most game engines are constrained by the amount of memory available on the target hardware, they implement custom memory tracking tool that allow developers to see how much memory is being used by each engine subsystem and whether or not any memory is lacking. So this feature has shown the stat memory usage of the game, which enabled the developer to do the memory tracking for any other devices. So these are brief talk about the tools that will be used by developer in order to debug and test the game. And this is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh to Prof. My name is Indra Akwan Rahman, reference number A1 and EC0042. So today I'm going to present the condition of depth bubble triangle rasterization. So depth bubble is a type of data used to represent the depth information in 3D space. As you can see here, this is on how the basic step on rendering a 3D scene. This is the example of the depth buffer and triangle rasterization. Next is the primary goal actually is to create looks like a photorealism and also use a light transport models. So each object must occupy volume of 3D space and object also white and opaque, transparent or translucent. Next. Theoretically, a surface is a 2D shape. The high-end film using subdivision surface and some are using rectangular patches. And most basically, they are using the properties of the triangle. Same goes to the triangle mesh, also using the property of a triangle. Division is a process of dividing the surface of a collection of a discrete polygon. LOD have been learned in RTCG, which is a level of detail for each object when the object is close to the camera. And then constructing a triangle mesh need a winding order, which is it has an equation and also can be SP1, P2, and P3, and also has a cross product. Next is triangle list and index triangle list. So they are categorized by a group of 3 and also use a lightweight vertex indices and can be defined as a triples of vertices. And then as you can see in the image here, there is a difference between the triangle strip and triangle fence. For the model space, focusing on the typical as typically aligned with natural front, left, right, and up. And there is a 3 vector which needs to know, which is I, J, and K. For the workspace, basically workspace more focused on positioning and orienting, and can be referenced to share mesh data. And visual properties is needed to render and light surface properly. For light and color, each object has a light, and light is a electromagnetic radiation and can be determined. The color itself can be determined by the intensity and wavelength. It also can be light also can do both, which is absorb, reflect, transmit, and diffract. For the color model is a 3D coordinate system to measure the color. Meanwhile, the color space is to see how numerical color in particular model should be. So basically, this can be seen in RGB color. For the vertex attribute, we need to know the position vector, vertex normal, vertex tangent, diffuse colors, vector color, vector coordinate, and scalar weight. And then for the vertex formax, this is the coding on how the vertex might form. This is the correct shading and the foam shading. This is more focusing on the shading. So we have learned it in the advanced photography and also XCG. And then lastly is a vertex normal and smoothing. So lighting is a process of calculating the color object in the various point. So on how to smoothing, vertex is needed to match the significant effect. So I think that's all from me. Thank you.
Good day to Prof. Shafri and Dr. Edora. My name is Ashwin Saran Sharman from Computer Games Development Section 2, and today I'll be talking about the foundations of depth buffer triangular rasterization. So the first slide is about textures. So textures are images that are mapped onto a geometry to give it a realistic appearance. These textures are applied using texture coordinates, and they specify how the texture is applied on the geometry. And these textures can be stored in different formats, such as compressed or uncompressed. And one of the techniques used to create multiple levels of detail for a texture is called MIP mapping, and it is used to improve performance and reduce aliasing. Anisotropic filtering is also a technique which is used to improve the quality of textures when they are viewed at an angle. So some of the example textures are here. Moving on to the next slide, which is materials. So materials describe the visual properties of objects such as the color, reflectivity, and transparency. And these materials can be defined using various techniques such as physically based rendering or artistic hand tuning. The shading models are used to calculate the color of a pixel based on the properties of the material and lighting in the scene. Different rendering techniques can be used to simulate different materials such as subsurface scattering for skin or faux shading for hair. Brick materials applied here, and it looks like brick, and with here there is no material applied and it just looks plain in color. Moving on to the next slide, which is lighting basics. Lighting is actually the process of calculating the brightness and color of each pixel in a rendered image based on the position and properties of light sources in the scene. So there are three important lightings that the games usually use, and one of it is called ambient lighting, where it simulates indirect lighting that illuminates object uniformly. So you can see here the light is constant, whereas diffuse lighting simulates direct lighting that illuminates object uniformly from a light source. So you can see the example of diffuse lighting here. And meanwhile, specular lighting is quite different, where it simulates the reflection of light off shiny surfaces such as metals or glass. As an example, you can see here. And we combine all these three lightings into what is called a form reflection. Okay, moving on to the next slide, which is virtual camera. So the V-space is actually a coordinate space where the objects are transformed from the world space into a coordinate system relative to the camera's position and orientation. Projections are used to project a 3D world onto a 2D scene, and there are two main types of projection: perspective and orthographic projections. We can see an example of both of these projections here. And the view volume is a pyramid-shaped volume that represents everything that the camera can see, and it is defined by the camera's position, orientation, and field of view. So this is the view volume, and the frustum is actually a truncated pyramid that represents portion of view volume, and that is equal to the screen. So this frustum is actually here, and it's used to determine which objects are visible and which are not, and it is also used to perform addition, occlusion, culling in gaming.
Thank you.
Good afternoon, my name is Lokesh. This is going to be my presentation for the reading assignment task 1 for computer games development. So we move on with my chapter is chapter 11, starting with subtopic 11.1.4, which is the virtual camera. So the first is projection and homogeneous clip space. So what this basically is, it covers the use of projection and clip space to create in-depth perspective and depth in game graphics. So we use this to discard or clip objects that are outside of the player's view to help improve performance and also create a level of detail for the game. The next is screen space and aspect ratio. So this is very simple. This is just basically part of the game where it controls the size and shape of the screen size, because there's all the different types of screen sizes. The photo is an example, some of the examples. And also what this basically is just the ratio of the screen width to its height. So that's why they call it an aspect ratio. Okay. So the next is the frame buffer. So frame buffer is actually a simple thing. It's a portion of a memory which is used to store the color and depth information. So as you can see in the simple diagram on the left here, so the bits are temporarily stored in the frame buffer before they go through all the elements for the colors and also be to the final output of the display. So we use that to display, the frame buffer will be used to display the final rendered image. Next is triangular rasterization fragments. So this basically covers the process of rendering a 3D object onto a 2D screen. So as you can see in the image there, we break down all of the objects into small rectangles and then we try to render those rectangles. This basically works in anti-aliasing and all of that to create a much more better looking image. Next is occlusion and depth buffer. So occlusion culling is basically we reduce the number of objects that need to be rendered. So as you can see in example seen here, there's a lot of different, there's walls and also there's a character and all that. We use the depth buffer and occlusion to see which is the object in front, which is at the back, and also the render distance and all of that. Okay, so it's a short example, short compilation. Next is subtopic 11.2. So we start with the rendering pipeline, an overview. So it's just a high-level overview of all the pipeline stages. This is an example overview of whatever we have. So ours is several stages: tools, asset, conditioning, application, geometry processing, and rasterization. So we move on to the first one, tool stage. So this just involves various use of tools to optimize game performance, to create visually appealing game, for tools that developers and graphic designers use to create models, textures, and animation. Next is asset conditioning. It's just a series of operations such as converting file formats, compressing data. So we use all of this to create the end result of the game, because there's all the different components and also optimization and all that we need to do to create the final game. Next is GPU pipeline. So this is where all the processing, all the assembly, rasterization, processing, all of that helps create the final output of the 3D geometry texture. Also all the shaders and everything that's being outputted by the GPU. So this is where it happens. Next is accessing memory. So this uses programmable shaders and also other small programs to run on the GPU to create customized visual effect in games. The final one is just a compilation of the rendering pipeline. So that's all from me. Thank you very much.
Everyone, I'm Omiran. Today I'm going to present the Game Engine Architecture book for the subtitle 11.2.3 Introduction to High-Level Shader Language. High-level shader language is like CG and GLSL are modules after the C programming language. They can declare function, define a simple struct, and perform the arithmetic. So there are three ways to define, which is semantic, input versus output, and the uniform declaration. So 11.2.5.3 is the effect file. So why we need effect file? Because the shader program isn't particularly useful, as some virtual effect require 2 or more rendering passes, but a shader program only describes the operation to be applied during a single rendering pass. So if we need to write a program game in a PC platform, so we will need to work even and other graphic cards. So there are 3 types of formats, which in CG we call CGFX, in ORG we call CGFX with the material file, and while in the GLSL we call Collada, which is based on the XML. So the hierarchical format 3, which at the global scope, structs, shader program, and the global variable are defined. Second, one or more techniques are defined, is represent one way to render a particular virtual effect. And the last is within each technique, one or more passes are defined, which is described how a single full-frame image should be rendered. Anti-aliasing is a technique that reduces the virtual artifact caused by aliasing, and the net effect of pretty much all of them is to soften the edge of render triangle by blending with the surrounding pixel. So there is some of the technique they use, which is first full-screen anti-aliasing FSAA, which is known as a super sampling anti-aliasing. The scene is rendered into a frame buffer that is larger than the actual scene. Second is a multi-sample anti-aliasing, which provides the virtual quality compared to FSAA while consuming a great deal less GPU bandwidth. Third is coverage sample anti-aliasing, which is an optimization of the FSAA technique done by the Niebla. So the fourth is the morphological anti-aliasing, which focuses its effort on correcting only those regions of a scene that suffer the most from the effect of aliasing. The last technique is subpixel morphological anti-aliasing, which combines the morphological anti-aliasing, MLAA and FXAA technique with multi-sample SSAA to produce a more accurate subpixel figure. So the application step, the 3 row, which is the feasibility determination, submitting the geometry to the GPU for rendering, and the last is controlling the shader parameter and the render step. So the advance of lining and global illumination for the topic 11.3. So there is 3 types of the image-based lining, which first normal mapping, which is specified a surface normal direction vector at each pixel. So the height map is typically encoded as a square image that can be used for path mapping, parents mapping, and the displacement mapping. When these 3 techniques is combined, they can make a planar surface appear to have a high variation. The third is the specular or the gloss map. This tool is different, as specular is determine how much light will be reflected of a surface, while gloss determine how clear the reflection will be. So that's all for my presentation. Thank you.
Good day, everyone. My name is Tangka Kun. Next, I will proceed to last 2 image-based lighting algorithm. First will be environment mapping, which is panoramic photograph of the environment taken from the point of view of an object in the scene. There are 2 common formats, which is spherical environment maps and cubic environment maps. Last one will be 3-dimension textures, which is a stack of 2D textures, and it will be useful for describing the appearance or volumetric properties of an object. Next, we will go to high dynamic range lighting, which is HDR lighting, attempts to capture the wide range of light intensity. It performs the lighting calculation without clamping the result, and in order to display on screen, a process contour mapping will be used to shift and scale the image intensity range into the range supported by the display device. By doing this, it will permit the rendering engine to produce many real-world visual effects. Okay, next we'll go to global illumination, which is a class of lighting algorithms that counts for light's interaction with multiple objects in the scene, which is on its way from the light source to the virtual camera. There will be 6 global illumination, which is shadow rendering, ambient occlusion, reflections, caustics, soft surface scattering, and pre-computer radiance transfer. Okay, next we'll go to deferred rendering, which is an alternative way to shed the complex scene with lots of lights that address problems such as different types of lights and different numbers of skinning weights. Majority of the lighting calculation will be done in screen space, and the rendering will store all the information we're going to need to light the pixels in the deep prime buffers, known as the G buffer. Next, we'll go to physically based shading, which approximate the ways in which light travel and interacts with the material in the real world. This allows the artists and lighters to tweak shadow parameters and use intuitive real-world quantities measured in the real-world units. Next, we'll go to visual effects and overlays. This renders the three-dimensional solid objects. A number of specialized rendering systems are typically layered on top of this pipeline and responsible for rendering visual elements such as particle effects, decals, which is a small piece of geometry that is overlaid on top of the regular geometry in the scene, environment effects such as skies and waters, overlays, which is text and fonts, gamma correction, and last one will be full screen pause effects, which is effects applied to a rendered three-dimensional scene to provide additional realism, such as motion blur. Okay, so that's the end of this chapter. So for further reading, you can go to reference 27, which is creating the three-dimensional computer graphics and animation for the games and films. That's all from me. Thank you.
Welcome to Profit Animation. So I'm Lemon. I would like to talk about animation system. So there are 5 types of animation, where the set animation is the first early cartoon animation technique, that specific type of traditional animation. They use the set animation technology that called as sprite animation. So what is the sprite? Sprite is the small bitmap that is overlaid on top of a full screen background image without interfering with it. So next is the rigid hierarchical animation. So this is the character animation for the 3D model. So it is the collection of rigid that is hierarchically constrained to one another. So for example, when we upper arm move, the lower arm and hand will follow accordingly. So the big problem of the rigid hierarchical animation is when the character body not particularly appealing. It causes of the cracking at the joint. So next is the converted animation and mouse target. So what is mouse target? Mouse target is the animation that small number of fixed that extreme pose are used. For example, facial animation. Because facial animation is the complex anatomy that driven by approximately 50 muscles. So next is the skin animation. Skin animation is the enhancement for game hardware, where for example, as you can see the character of a grand outer that met up with a mesh triangle, and then inside the body as the rigid one and joint that allow the skin to move. Alright. So the last one is the animation method as data compression technique. So basically, compression techniques is the technique to improve animation efficiency and effectiveness. So it's critical to weigh the benefit and drawback of various animation techniques, like internal skeletal structure with forward, whereas the motion of face is more complex. Alright. So next is the skeleton. So what is the skeleton actually? Skeleton is the character model that consider have a pelvis joint in the cranial vessel. So there is 3 things that very important in the skeleton. The first is the skeletal hierarchy. So the skeleton joints form a hierarchy or tree structure. Most of the skeleton that represented by a small top level data structure containing an array of data structure of each joint. Alright. There is 3 rules for each joint to data structure. Alright. So the first is the joint's name at the SS string or has a H32-bit string ID. Second is the parent just index within the skeleton. Third, the joint inverse bind process to transform. In this game design, we have 3 processes, which is the bind process, local process, and global process. So what is bind process? Bind process is have 2 different processes, like as you can see in the figure 12.7. There is a T process and the bind process. Bind process is known as the reference pose or rest process. Alright. So next is the local process. What is the local process actually? Local process are almost always saved in SRT format when we talk about animation learning. For example, Maya 3D or 3D package represent joint graphically as small sphere. So here is the image that Maya allows the user to see a joint local coordinate axis. Alright. So next is the global process. So what is the global process actually? Global process is to express a joint process in the model space or world space. So some game engine express global process as a matrices. Some use the SRT format like the bind process. Alright. So here there is the specific formula that we call as global process joint computer form. Right, lastly is the clips. So there is 2 clip, local timeline and global timeline. So what is the post interpolation actually? The animator generate that have 2 posts like key post or keyframe. So for the time units, basically measure for the unit of second. So for what is the frame and the sample? Frame is taken to be a period of time. For example, refer to a single point in the time. Alright. So the loop for the clip basically designed to be played over and over repeatedly. So there is 2 rules. The first one is for non-looping, and the second one is if the clip is looping. So basically the normalized time useful for synchronizing two or more animation clips that are not necessarily of the same duration. So what is the global timeline? For the global timeline, it's used to calculate the type of animation. So basically it simplify synchronization animation and keep track of the time indices when playing the animation.
Assalamualaikum and good day to Prof. Sharizal and Dr. Idora. So my name is Pengeran Karel Kais, metric number A19EC0147. So I will be presenting my topic, which is animation systems. So from chapter 12.4.3 until chapter 12.6.22. Okay, so first we need to know about local clock. So there are two, local clock and global clock. I will be explaining the global clock later. So first, local clock. So local clock basically in a clip, local clock starts at the beginning of a clip. So once the clip has started, the local clock will start. So take a look at the second one, which is the global clock, which the clock will start when the character is spawned or the level has started, and it stores in unit of second, which the main function of global clock is to control multiple clips for different character to synchronize. So which is easier to synchronize since the clock will start the moment all of the character are spawned. So the next one is relationship between mesh, skeleton and clips. So the UML diagram here shows that so inside a mesh we have vertex. So mesh is the skin or the outlook of the character or model. So how do we move the character is by putting a skeleton in them. So skeleton, they have joint, so where you have the body, and then the body connects to the leg. So basically there's a joint there where you can move the leg but the body won't move, so it works like our skeleton. So for the model to move or to animate, they need to have animation clip which move the skeleton. And next is animation retargeting. So you can implement multiple of animation in one skeleton by animation retargeting. So animation retargeting stands for using an animation altered for one skeleton to animate a different skeleton. So in the diagram there shows that there are three skins, skin A, B and C, so meaning three different mesh, but all of them have the same skeleton. For example, you have two people, two different models, so a girl and a guy, and they both have the same skeleton, a human skeleton. So you just implement the clip into the skeleton and it will work. So you need only one animation and you can implement it into a different model. So that's what animation retargeting stands for. So that's all from me. Thank you.
Hi, my name is Siti Fatima Azahra, and this is the video for my task 1 game engine architecture, and I'm going to explain from 12.6.2.3 to 12.8.2. So the first one is directional locomotions. So lerp-based animation blending is often applied to character locomotions. Lerp stands for linear interpolations, and there's two types of character locomotion, which is the targeted movement and the pivotal movement. So the targeted movement is when the directions of the character facing and the direction the character move are independent, and the pivotal movement is when the directions of the character facings and the directions of the movements are the same. So these are a few types of complex lerp blends. The first one is generalized one-dimensional lerp blending, which is by selecting two clips immediately adjacent to it and blend them together. The second one is simple two-dimensional lerp blending, is to smoothly vary two aspects of a character motion simultaneously when the animation clips to blend lie at the corner of the rectangular regions. The next one is the triangular lerp 2D lerp blending, which is same to smoothly vary two aspects of a character motion simultaneously, but between an arbitrary number of clips positioned at arbitrary locations. The last one, same with the triangular 2D dimensional lerp blending, but it uses a technique known as the Launay triangulations. Next, we're going to talk about the partial skeleton blending. So this is to move different parts of a body independently. So partial skeleton permits the blend percentage to vary on a per joint basis. Blend marks is created in which the blend percentage are 0 everywhere except joints used by the character when they are equal to 1. However, there's a few problems with partial skeleton blending. The movement look unnatural. This is due to the human body never totally independent, and second, the abrupt change of the joints. So in order to fix this, there's another blending, which is additive blending. Basically, additive blending introduces different clips represent the difference between two regular animation clips. And a different clip encodes changes that need to be made in one pose in order to transform it into another pose. So you can imagine there's two clips, clip A and clip B, and then there's third clip. And the third clip we blend together to make changes from the first to second clips. The difference between additive blending and partial blending, it suffers less from the disconnected look from the partial blending. The limitations is tendency to over-rotate the joints in the skeleton. So in order to reduce the over-rotate, there's 3 rules for this. So the application of additive blending can be at stance variations for the locomotion noise, aim and look at, and finally overloading the time assist. Next is post-processing. So there's 3 types of post-processing. The first one is procedural animations. So procedural animation is animation generated at runtime rather than being driven by data exported from an animation tool. The second one is inverse kinematics. It's an attempt to bring an end effector joint into a target global pose by minimizing the error between them. And lastly is the ragdolls. A ragdoll is a collection of physically simulated rigid body, each one representing a semi-rigid part of the character body, such as his lower arm or his upper leg. Next, I'm going to talk about compression techniques. So there's 2 types of compression technique. The first one is channel omissions. It's one simple way to reduce the size of animation clip to omit channel that are irrelevant. So this technique can significantly reduce the size of animation clip. The second technique is quantizations. It's by reducing the size of each channel. The 2 components to quantizations are encodes and decodes. So encoding is the process of converting the original floating points value to a quantized integer representations, and decoding is the process of recovering an approximations to the original floating point value from the quantized. So that's it from me. Thank you so much.
Good day, Prof. Sharizal. My name is Roshan Dev Daniel, and today I'm going to be talking on the Game Engine Architecture book in which we were tasked. And so for my chapter, we learn on animation. And so we learn on the sampling and frequency key omission, which is how the animations are affected either by their weight or their structure, and how we compress it to ensure the size of it is kept, which is using curve-based compression, wavelet compression, and the fact that in games, we don't have to load every single animation, and that's why we learn on selective loading and streaming. We also learn on the animation rendering pipeline, in which there are 6 steps. Firstly is the decompression and post-extraction. And once step 1 is done, we move on to step 2, which is the post-blending, then to step 3, which is the global post-calculation, and then to step 4, which is the post-processing, and then back to the global post for step 5, before we move on to the matrix palette, before the animation is sent to the rendering engine. We also learn on action state machines, which is a way to ensure the animation moves from one state to another state correctly, such as running, one leg moving from walking state to running state. And we have 4 different methods and examples, such as the flat weighted average approach, the ogre animation, the granny animation, and the crossfades with flat weighted average. We also have blend trees, which are an expression tree or a syntax tree, where the interior nodes and operators serve as the inputs of those operators, which helps in the state of the animation. So you have binary loop blend trees, generalized one-dimensional blend, two-dimensional loop blend trees, additive blend trees, layered blend trees, and crossfades with blend trees. We also have state and blend tree specification, in which we learn on examples of the Naughty Dog engine and Unreal Engine 4, in which the Naughty Dog engine used a text-based approach, and Unreal Engine 4 allows its users to use multiple approach in creating a state and blend tree specification for their animations. So we also learn on the kind of transitions that are carried out, which are such as the pop transitions and crossfade transitions in animations, the transitions parameters, where we have to take each state and find out what is the next step before we can carry out the transition, and the transition matrix, which in real game we have to take into conclusion that not all state transitions are possible, such as from a dead state, there's no other state that you can go to when a character dies. So that's all, and thank you.
Assalamualaikum, my name is Nurlinda. This is my presentation for task 1, where I have to read Game Engine Architecture book, and I will cover the part that is stated in the slides. So in this chapter, basically talk about how to make animation objects in game move in a realistic and natural way. And one of it is implementing a transition metric, where there are different ways to implement a transition metric. One of it is using spreadsheet application and incorporating transition into the same text, and also adding transition into a graphical user interface for state editing. For control parameters implementation, there are some challenges where sometimes the control parameters are buried within the tree, requiring prior knowledge of the tree structure to control them. But how animation engines solve this is there are different ways, such as node search, name variables, or control structure. And however, every animation engine tackles this problem in slightly different way, but the net effect is roughly the same. And next is constraint. Constraints are imported in character animation control to limit movement and characters, objects, and scenes. So example of constraint is like weapon, position, characters alignment, feet alignment with the floor, and hand alignment with object. And the function of the constraint is animation system typically use constraint to ensure the character objects move in realistic and natural way. And the technique to use constraints is use various such inverse kinematic IK or other mathematical algorithm. And lastly is attachment. Attachment is actually an object to object attached together. So attachment involves constraining the position and or orientation of the object's joints. So the attachment has joints. So adding joints attachment purposely is not always feasible due to processing and memory costs. So attach point can be modeled in Maya as joint or locators or specified by a custom GUI in animation authoring tool. So after talking about the animation, the chapter 13 is talking about collision and rigid body dynamics. So it's basically about adding a physics into the animations in the game. Adding physics in game may have impacts in design impacts and engineering impacts. So first, design impacts is it will predictably may be affected, and the tuning and control may improve by tweaking physics parameters, but it is often indirectly and difficult to visualize, and the emergent behavior may arise. And there are a lot of engineering impact when adding physics in game, but here's the three. The tools pipeline. A good collision physics pipeline takes time to build and maintain, and misbehave objects may be bounced to each other way in expected way or jitters badly. And ragdoll physics require a lot of fine tuning and often suffers from instability in the simulation. So that's all for me. Thank you.
Assalamualaikum, my name is Rishafina binti Ahmad. I will present impact of physics on game, which are art impact and also other impact, and also collision and detection system. So the first one is additional tool and workflow complexity. So this gives extra work to the developer because they need to combine multiple elements such as mass and also friction. Then more complex content, so need multiple visual for the object. For example, block destroy when the player attacks. So need to version which are original and also destructible. Then lose control, so unpredictable physical related impact will affect control of changing scene. For example, like glitch when the character movement. Then the other impact. So the first one is interdisciplinary, so need to have a close cooperation with several departments such as art and also audio. Then production impact, so add realistic element will increase the several rates such as cost and also technical. So these are the SDK and also engine that use in the physics. Collision and detection system. So the purpose is to determine whether any object would have a contact between each other by looking at the geometric shape and also shape overlapping. So the first benefit is to provide support to the object to allow the object rest in equilibrium state. Next is to cause them easily to explode when hit the target. For example, like allows player to boost their health. Next is rigid body dynamic will mimic physical realistic behavior such as bouncing and also rolling. And then how the collision detection system works is through the collidable entities. So the object have shape and must be transformed so that can position and orient properly. And next through the collision work. So the shape has rigid body, dynamic system, and associate with single collidable. And next is through the shape concept. So the collision SDK provides support for the surface primitive. So this can be described as region of space. In 2D have area boundary and 3D have volume and boundary. Next is collision primitive. So this way work with limited set of shape. First is AABB and then OBB and then DOP. The next shape is arbitrary convex volume, which is all the diagonal lies inside the shape. And then polyset, which is used to construct complexity geometry by using triangle and polygon. Next is compound shape, which is the object cannot build by a single shape. In the image, there have two shapes to build the chair, which are the first shape and also the second shape. How we can check the intersection in shape? The first way is point versus sphere. So you need to form the vector S between the origin to the any point. If the length bigger than the radius, so the point lies outside the sphere. Next is sphere versus sphere. So you need to do like the previous step, which is form the vector and then sum between two radius. If the length vector smaller than the sum to radius, the shape is intersect between each other. Next is separating theorem. If successfully forms separating line between two shapes means that the shape does not intersect between each other. Next is AABB versus AABB. You can apply separating axis theorem by inspect minimum and maximum coordinate. If overlap, so the shape is intersect between each other. The last way is by using GJK algorithm. So the first step is you need to do the Minkowski difference. So all point in the first shape must be subtract with all point in the second shape. So this is the calculation. Then plot the result. Then you need to set supporting vertex for any direction. So you need to put the supporting vertex at origin and see which point lies in the vertex. Then you need to repeat the step until form the triangle. If the origin lies inside the triangle, then the two shapes intersect between each other. But if does not lie, you need to repeat the step to test at all points. But if the origin still does not lie inside the triangle, means that the shape does not intersect between each other.
Assalamualaikum warahmatullahi wabarakatuh. Tutor Sharizal, my name is Wana Atika binti Junaidi, and today I will be presenting my part, which is 13.3.5.6 until 13.4.4. Okay, firstly is the collision testing and analytical geometry. There are two, which is first the ideal shape-sheet combination, which has large numbers, and there are two dispatch users, which are single and double. And for the second one is if objects not moving too fast, it uses static intersection test. But if moves so fast, it will encounter problem known as bullet through paper or tunneling. And the solutions are spreadsheets and CCD. Next is the performance optimizations. There are three, which are temporal coherency, spatial partitioning, and the phase. So the first one is avoid recalculating information by caching results. The second one is dividing space into smaller regions, and the third one is there are several phases to optimize the performance. Next is the collision queries. There are three: ray casting, shape casting, phantoms. For ray casting is a line segment, start point and end point. And then for shape casting, start point, distance and type, and the dimensions and orientation to cast. And phantoms acts like shape cast, but distance is 0. Next is the collision filtering, which enable or disable collisions between objects. There are three: masking and layers, callbacks, and collision materials. So for the masking is categorizing objects whether to collide or not. Callbacks is using callback function, and for collision materials uses a material system. And rigid body dynamics foundations, there are three: units, separability of linear and angular dynamics, and also center of mass. Units is the MKS system, M meter, K kilograms, and S is seconds. As for the second one is linear dynamics is ignoring the rotational effects, and for angular it includes the rotational effects. Center of mass is about the balancing. Next is the linear dynamics. So linear dynamics, there are two: velocity and acceleration, and force and momentum. Basically, these are the ones that we have learned in physics. So there are linear velocity, acceleration, force, and momentum. Next is solving the equations of motion. There are four: force as a function, ordinary differential equation, analytical solution, and numerical integration. So force as a function, it can be constant or function of time. ODE involving a function independent variable and various derivatives. Analytical solution is using closed form function, and numerical integration solved in a time step method. That is all from me. Thank you.
Hello, I'm Clive, and I would like to present the topics today from 13.4.1 to 13.4.7.7. The part 1 is about numerical integrations, which consider explicit-Euler and Bellot methods. Explicit-Euler is simple integration methods used to produce a better result when the velocity is nearly the same all the time. The Bellot integration is using Taylor-Swiss method and is harder to use but produce better precision and good result than Euler. The part 2 is about angular dynamics in 2D, where this angular dynamics only occur in xy plane and not consider z-axis yet. The angular speed and acceleration formula is given here. Also, the moments of inertia is a core concept here. After that, the torque is also important to be considered. So when the force is hitting the body, it will cause the rotation. And then these are the angular equations used to solve the motion in 2D. In part 3, also the angular dynamics in 3D, we need to use the inertial tensor to calculate the motions, and also the orientation in 3D is using the matrix or quaternion unit. The angular velocity and momentums in 3D is given, the solution is given below, and the torque in 3D is more complicated than the 2D. So these are the equations that used to solve the angular motion in 3D. Part 4 is about the cohesion response. So the energy that we use is the kinetic energy here. And then the impulsive cohesion response is also the core concept for this part, and we use the Newton's law as well. The next thing is about we used to use the p-hats method to calculate the cohesion and the impulse. After that, penalty force is an imaginary force that used to control the interpenetrated objects, and we also could use the constraint method to resolve the equations. The friction also the very important concept here. The formula is given below, and also the welding concept they used to solve the object when hitting together. Coming to rest island and stripping is the method used to optimize the performance issues. There are also some of the physics criteria we need to consider. And coming to rest island and stripping, this means that we strip the whole calculation in groups. These are the topic required today, and that's all about my presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq bin Halim, and this will be my video for chapter 13.4.8 constraint. First is constraint. What it is a method used to model certain behaviors inside a game. Then we have six constraints, which is first point-to-point constraint, stiff spring rod constraint. The third one is a hinge constraint, a prismatic constraint, a constraint chain, and also ragdolls. Okay, most physics engines typically provide the users with a number of ways to exert control over the bodies, and here we have 4 of it, which is gravity that exists mostly in games, force that can be applied to a body. Then we have impulse, a force for instant change of behaviors or direction of a body. Then torque, which can be spin to change direction. Then we have integrating a physics engine into your game. First is linking game object and rigid bodies. This involves in connecting physics simulations with game objects, then physics-driven bodies, object in game that move and interact according to the law of physics, game-driven bodies, the objects that are controlled by game codes and can be altered by developers using logic and rules. Then we have the fixed body, a special type of rigid body. Then lastly, Havoc's motion type, which categorize object into static, dynamic, or keyframe, then determine on how the object behaves in a simulation. And here we have updating the simulation, which is the step to completely update the physics simulation. There's 7 of it. First is to update the game-driven rigid body, then update the phantoms, followed by update force, apply impulse, and adjust the constraint. Next is to step the simulation and update the physics-driven game object. And 6th step is to query the phantoms, followed by the last step of performing collision cast queries. Last one is to use collision and physics in games. Okay, there's 4 of it. First is the use of simple rigid body game objects. Example, sticks and stones, the objects that can be picked and thrown. Second is use of bullet traces. Example, use of lasers and bullets. These are affected by gravities. Then the creation of grenades that can bounce and be limited by using air drag or manually managed. Then explosion that mimics their sound and created blast effect and also surrounding damages.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mamale bin Johar. In this video, I would like to present the review of the book named Game Engine Architecture by Jason Gregory. So for the chapter 30.5.3, it will explain the example of uses of collision and physics in the game. But I will explain another 4 use example, which is destructible object, character mechanics, camera collision, and ragdoll integration. So for the chapter 30.6, it explained the advanced physics feature. There are seven physics feature, which is deformable body, cloth, hair, water surface simulation and buoyancy, physically generated audiosynthesis, general fluid dynamic simulation, physically based audiosynthesis, and general purpose GPU. So we will go to the chapter 14, which is audio. So the graphic engine is charged with the task of reproducing as accurately and believably as possible what the player will actually hear. Meanwhile, the audio engine is charged with the task of reproducing as accurately and believably as possible what the player would actually hear. So for the chapter 40.1, which is the physics of sounds. So sounds is a compression wave that travel through air, and sound also is a dynamic phenomenon. Actually, the sound pressure varies over time. So there is a property of the sound wave. The sound wave consists of the repeating pattern characteristic to instrument. So in the chapter 40.1.2, they explain the loudness of the decibel. In order to manage for a dynamic range of sound pressure variation, we measure sound intensity and the unit decibel. So for the sound wave propagation, the developer usually model the absorption and reflection in our virtual sound wave. There are actually 5 model of absorption and reflection, which is fall off the distance, atmospheric absorption, phase shift and interference, which is a multiple wave interacted, reverb and echo, and lastly the Doppler effect. So in the chapter 40.1.4, which is perception of position, explain the human auditory system that involved to allow a reasonably accurate perception of the position of sound in the space around us. So they actually the 4 element in that affect the position of sound, which will fall off with distance, atmospheric absorption, having a ears, and the ear shape. I think that's for my part in the review of the game engine architecture. Thank you.
Assalamualaikum and good day, Prof. My name is Nur Arini binti Nur Halil. Today I will explain about audio. Signal is function of one or more independent variable describing the behavior of physical phenomenon. Signal have 2 types, signal a continuous time and signal a discrete time. This signal can be manipulated, for example reflect, t equals to 0, replace t with negative t, or time shift. Signal to the right, positive direction, by distance s, replace t with t minus s. Time variant, a time shift in the input signal cause an equal time shift in the output signal. LTI useful for 2 reasons, well understood and easy to work with mathematically, and many real physical system in the field of audio propagational theory, electronics, mechanics, fluid flow that can be modeled accurately. Next, the unit impulse. Discrete time use delta square bracket n, while continuous time will use delta bracket t, using an impulse train to represent a signal. This is the formula for time-shifted discrete unit impulse, and this is the formula for time-shifted continuous unit impulse. This is the default value for the convolution. We have 2 types convolution, which is convolution sum and convolution integral. So these 2 equations give a way to calculate LTI systems. In continuous time, everything works same as discrete time, but the only difference is the summations between integral and needs to include the differential. Visualizing convolution. There are 4 steps, which is plot x, t. This symbol is meaning the variable, and then plot hash t minus variable, multiply the 2 signal across the t axis and integrate from negative infinity to positive infinity along the t axis to find the area under the curve. Next topic is about analog audio technology. The first one is microphones. It's a transducer that converts an audio compression wave into an electronic signal. Different microphones have different sensitivity patterns known as polar pattern. The first one is omnidirectional mic, sensitive in all directions. Second, bidirectional mic, 2 sensitivity loops in the shape of a figure 8. And last, cardioid mic, a unidirectional sensitivity profile, somewhat heart shape. polar pattern. Speaker is a transducer that converts a varying input voltage signal into vibration in a membrane. Stereo is sound system that support multiple speaker output channel. For example, iPod, sound system cars. Next, we have surround sound to immerse the listener in a realistic sound space. We have analog signal levels. Audio voltage signal may transmit at various voltage level. Passing a voltage that too high for the device to handle will cause clipping of the sound signal. Passing a voltage that is too low will result in output that sounds quieter than it should. That's all for me. Thank you.
Assalamualaikum and good day to Prof. Shahrizal. My name is Nasrita Shkiminti Yusof. In this video, I'm going to talk about a book that I had been read under the topic of rendering audio in 3D. Basically, in a 3D game world, we need the 3D audio rendering engine. This is because we want to make the game becoming more immersive and also can perceive the player when they play the game. There are two types of elements in the 3D audio rendering engine, which is the first one, input, and the second one, output. Input is coming from all over the 3D sound that already emitted in the game world. Everything that's coming from the game, that is the input. And then output is the when sound is played through the speakers. This is to make the player believe that they are playing the game as in the virtual game. So that next one is the 3D sound rendering. Basically, there are 5 types of 3D sound rendering. The first one is sound synthesis, and then we have Auka speaker modeling. Second, we have Doppler shifting. Next is the mixing between 2D and 3D sound. Last but not least is the spatialization. Spatialization is the illustration that 3D is coming from the game world. There are 2 types. The first one is the distance-based attenuation. It's to reduce the volume of 3D. Imagine a circle, and at the circle of the at the center of the point, there is a sound resources. So when the player is coming near to the sound resources, the volume will be heard fully. So that's we call F omes, and that F omiss is when the sound is considered silent, meaning that the player is far away from the sources of the sound. And then the second one is the panning or pan. Is to provide the illustration where is the sound is coming, either from the left or the right. Given the example of distance-based attenuation and also pan. So for the pan is the PUBG Mobile. For example, in this game, when the enemy is coming, the player can hear from which direction the enemy is coming, either from the left or the right. So it uses the panning method. And then the second one is the distance-based. In the forest survival horror game, when player is near to the zombie, the sound of the zombie is very loud, but when the zombie is far away, it's very slow to be heard. Next is the realistic soundscape. For the realistic soundscape, it's actually produce what the ear perceives using the LTI system model. So basically, in a room, there are a lot of objects in surrounding. So all of these objects have their own specific sound. That's why we can play any sound location, but here at the position of the listener. That's all from my book summary. Thank you.
Assalamualaikum and good day. My name is Yama Zabira. I will be continuing chapter 14, which is rendering audio in 3D. So my topic is reverb regions. What is reverb region? Reverb region is a virtual area in the game that is defined with specific acoustic properties to stimulate the effect of sound, reflections or reverberations in that area. So how it works is it annotates the game world with manually placed region and then tag it with appropriate reverb settings such as pre-delay, decay, density, and diffusion. And one of the technique is by cross-blending the reverb settings for dynamic listening experience. There are 3 impacts of object and surface on sound transmission. The first one is occlusion, which is the first picture. This is when there is no path from the sound source and to the listener. The second picture is showing obstruction. This is when there is indirect path from sound source to the listener. Meanwhile, direct path is blocked from sound source to the listener. Lastly is for exclusion. The third picture. This is when there is free direct path to the listener. Meanwhile, indirect is blocked. We moving on to audio engine architecture. This architecture is called as audio hardware software, or also known as STEP. Audio hardware at the bottom, or also known as sound card,
provides acceleration to the software. The software is drivers and low-level API. So on PC, audio hardware is encapsulated in driver layers. And for PC and game consoles, the hardware and the drivers are wrapped in low-level API. On top of that, we have 3D audio engine. This is audio processing pipeline. So the first one is dry digital signals will be synthesized for each sound, and then the distance-based attenuations will apply to dry signal, and meanwhile for reverb will apply to wet signals to create a 3D audio. And then the dry and wet signals will be panned to one or more speakers to the final 3D sound. After being panned, the sound will be mixed and will be sent through speaker outputs or directly to digital output. There are three ways to manage sound asset. The first one is sound queue. The sound queues is a collection of audio clips and metadata that describe how they should be processed and played. The second one is sound bank. So sound bank is like cost units that package sound clips and queue into single file. For streaming audio is for long sounds. So the technique is by preloading a small chunk of the long sounds into buffer and play it normally.
Assalamualaikum everybody, my name is Nora Galita. In this video, I'm going to talk about the review of game engine architecture book. The topic is mixing your game. In this topic, we will be talking about the technique of mixing sounds. There are a few techniques of mixing sound that the goal is to avoid sound damage. The first technique is to mix the audio by groups. This is to categorize sound cues and physically mixing the groups into single signals so that you can control entire category at once. And the second technique is by ducking. This is to reduce sound signal so that the other signal can be more audible. To implement this ducking technique is by routing the sound signal into dynamic range compressor, which is then to analyze the signal and compress the loudness. The next one is bus presets and mix snapshots. It is a configuration parameter that control aspect of component onto a single bus and also gain control. Next one is install limiting. This is to control the number of sound that is played at the same time so that it can prevent sound damage. And the last technique is to mixing in-game cinematics. In-game, the virtual microphone or the listener will be detached and positioned towards the game character so that the sound of game characters will be more audible. The next subtopic is the game-specific audio feature. This one is split screen support, which is to handle sound so that it can produce appropriate sound for multiple listeners. The next one is physics-driven audio, which is to play appropriate sound for dynamic physical objects so that it can be a response to its impact. The next one is dynamic music system, which is for audio to adapt real-time event, mood, and tension. Next one is character dialogue system, which is to have a realistic communication between character and player. The next one is sound synthesis, which is to combine waveform at various volume and frequencies. The next one is crowd modeling, which is multiple the layer of sounds so that we can render crowd sound. The next one is the in-depth theory of character dialogue system. The first one is to give a character a voice, where for this we catalog all possible lines and provide various things to say. The next one is define dialogue line, where the dialogue line will be defined separate file for each character. Next is playing dialogue line, which the dialogue line will be stored in array and then randomly shuffled. The next system is priority and interruption, where the dialogue line will assign a priority level. Higher priority dialogue line can interrupt the lower priority dialogue line. The next one is conversation, where it can construct conversation between character and player. The next one is about interrupting conversation, where it compares the priority and interaction theory. Higher conversation can interrupt the lower priority conversation. Next one is exclusivity, where there are three types. The first one is non-exclusive. This line or conversation can be played over the top of others. The second one is faction exclusive, where a line or conversation can interrupt others in character faction. The last one is globally exclusive, about a line and conversation interrupt others across the faction boundaries. The next one is choices and branching conversation. This is to provide one or more alternative dialogue lines. And the last one is about context sensitive dialogue, to mark up region with location text that consists of two, which are specific tag and also general tag. So that is all from me. Thank you.
Hello and good day to CRAFT. Today I will be presenting task 1. Firstly is dialogue actions. Each line of dialogue could have a script associated with it that is synchronized with the audio. Next is music, which sets the tone, track the pacing of tension, and also can make an emotional scene. Moving to the next chapter, there are two elements in it, which are dynamic elements and also static elements. Dynamic elements usually more expensive than static elements in terms of CPU resources. The higher the ratio of dynamic elements to static elements, the more alive the game will. Here are some examples of the elements. Next is world chunks. When a game takes place in a large virtual space, usually it is divided into discrete playable regions. This is as a mechanism to provide greater variety of gameplay. So here is an example of chunk 1 and chunk 2 that is divided into regions. Next is high-level game flow. It is a sequence, tree, or graph of player objective. It provides the definition of success for each objective and the penalty for each failure. Next is implementing dynamic elements game objects. So the game's object model is a specific OOP interface intended to solve the particular problem of simulating or any game. Here are examples of the object models. Next is a few examples on tools that are used to develop the game model. Next is data-driven game engines. Here are Rust, which is famous because it is fast and has built-in parts. Here are the examples of the game that is data-driven, which is Baby, Amethyst, and Fireworks. Last but not least, here are some features in Game World Editor. Firstly is world chunk creation and manage. It allows new chunks to be renamed. Next is game world visualization. It has 3D and also 2D. For navigation, it has zoom in, zoom out. Player will be able to scroll. Next is selection. Editors allow single object to be selected at a time, or can also permit multi-object selection. Next is layers. Property grid. For example, the checkbox, drop down, and also control up and down. Object placement and alignment aids. Just like in Unity, it has like the position, orientation, scale of an object, translation, rotation, and scale tools. Last but not least is special object types. For example, lights, particle emitters, sound sources, regions, and other custom data. Thank you.
Good day, everyone. My name is Ong Hui, and I'm from Section 1. So in this video, I'm going to show you the Unity tutorial for making a rock paper scissors game using Unity. Then we start from right-clicking on the hierarchy and go to UI and choose the canvas to create a canvas. Then we click on the canvas and adjust the canvas color. Next, we need to create a text object for the result. First, we right-click on the hierarchy, go to UI, Legacy, and click on text. So we name it as result text. So basically, this text object will display the result of each round, which is win, lose, or draw. So now we set the font size into 150 and adjust the alignment and horizontal and vertical overflow. Then we're pressing R to rescale the size of the text. Next, we're going to create 3 buttons for the player to select their choice. So first, right-click, go to UI, Legacy, button. So repeat this step 2 more times. Then we just delete the text inside it since we don't have to use it. Then we rename the button first. Now we need to adjust the width and height and adjust the position of the button. After we have adjusted the position and the width and height, we need to create another 2 new images which represent the player choice and computer choice. So first we right-click, go to UI, and choose image to create an image object. First we rename it player choice. After we finish adjust the size and position, we create another 2 text game objects in Legacy text. Then we name it as player and computer. And we need to assign them to their respective choice game object. we need to add image for the rock, paper, scissors button, as well as the question mark image for the player and computer image. So before we drag, we change the image. We need to make sure the image that we find, their texture type is sprite, 2D, and UI. If not, then we just simply click on it and change to sprite. Then we click on the apply button. So after we have dragged the sprite to the source image on the inspector, next we need to download and import the RPS script Unity package, which is provided in the tutorial PDF. Then after importing the Unity package, we'll have access to all these scripts as shown in here. So now let us create an empty game object. Right click, create empty, and name it as game manager. So we attach the game manager script to this game object on the inspector. Next, we drag the button script onto the rock, paper, and scissors. Then we assign for each button as 1, 2, and 3 respectively, and we need to also assign the game management to the inspector here. We need to create another text game object that will become the advice to the player to choose their button. So next, we need to create an audio source game object. Right click on hierarchy, go to audio, and click on the audio source. So basically, this audio source will be used to play sounds effect for winning, drawing, and losing. So now we rename it as sounds effect. Now we click on the game manager, and we assign all the required fields in the game manager script. And for the sound effect, we need to add win first, and then draw. Lastly, the lose sound effect. And for the audio source, we assign the sound effect audio manager into here. So this is what it looks like after we have complete all the steps. So let us try now. So everything works fine, and it is easy to do it if you follow step by step. So I think this is all for my video. Thank you.
Assalamualaikum, my name is Kudrami Muhammad Safi'i, and this is my video presentation for Computer Games Development Section 1, which is Game Engine Architecture presentation. So my first topic is property-centric architecture. So it is defined as set of all properties that a game object might have, and it is most implemented in most of cases in a properties themselves or via script code. So first one, I'll be explaining about implementing it in a property classes. So it is determined by the aggregation of the behavior of all of its properties. So let's say I'm making a health property, and also we're making like receiving damage or making changes to the health. So it will change the property like decrementing HP accordingly, and also can communicate with other properties such as animation and rigid body. When receiving damage, it can make an animation for it, so it produces some cooperative behavior. So other than that, we can implement it in via script, which is like a block of script code, and the property values are in raw data or more database like table. So comparing properties and components, properties objects are very closely related to components in many ways. So properties is more centric design, and each subject defines a particular attribute of the game object. And for the component, the subject often represent linkage to particularly low-level engine subsystem. So the main distinction is these 2 points, but however, this is kind of irrelevant in most of cases for me. And this is the pros and cons. So for pros of property-centric design is memory efficient, easy to construct, and cache-friendly. So by storing, this is more optimized for most of modern gaming hardware. So like by storing data contiguously in RAM, we can reduce or eliminate cache misses. So the cons for this is much more difficult to enforce between properties and much more trickier to debug such as. Next is loading and streaming game worlds. So to manage the file input output, it is necessary to load the game world chunks and other needed access from this. So for this example, game world is divided into chunks. So the level load each with requested chunk are arranged in such way. So you can see here, So it's guaranteed that player never sees when the chunk pop in or out whenever the load is going on. Next is save games. So in save game, it allows the player to save their progress. So whenever they quit the game and load up a game at a later time, it exactly in the same state. So one of the method to save a game is by making a checkpoint, which limits the specific points in the game. So I think that is all from me. Thank you.
Assalamualaikum. Hi, my name is Daniel, and today I'm going to talk about property-centric architecture. So think of it in terms of object that contains attribute, data members that contains behavior and member function. It's akin to relational database that an object, and this used quite a lot in very successful commercial games. Pros and cons of property-centric designs. So the pros are memory efficient because we only store data that's what's needed, and also it is easier to construct model in data-driven manner. So it's define new attribute easily without recompiling the game. So be cache friendly. And the cons can be challenging to construct for big scale behavior. Debugging such a system is also significantly more difficult. So, world chunk and data format. So the game world loading system has two main responsibilities, which are it's to load the game world and the assets needed, and it's to manage the process of making it into the memory, and also manage the allocation and delocation of memory resources. So the important thing is we have to, when we load the level and then load the games into the world, the chunks, and also necessary to unload it, because when you don't unload it, the memory will, and it will go to memory leak. So the allocating memory is really important here. Loading and streaming game worlds. So how do we determine the set of world chunks? So when we see here, we take the union of the chunk list from each of the region, and then we load the system periodically to the master chunk and compares it against of world chunks that currently in memory. So it's designed in such way to ensure that the player never sees a chunk disappears. Save any file. Save anywhere that allow player to progress virtually. Also save whenever and anytime they play. So the size store of this game data file must drastically grow because it needs to store every little detail that the player have. So I think that's all from me. Thank you for watching.
Assalamualaikum and a very good evening. My name is Haziq Hafi, and today I will present my chapter 16. So the first one is object state caching. State caching can improve consistency by allowing objects to safely query each other's previous state vector without regard to update order. State caching guarantees a total consistent state vector will always be available even during the update of the new state vector. State caching consumes twice of the memory of the update in place approach and only solves half of the problems. This technique is influenced strongly by the design of principle of pure functional programming. Next is timestamping. Timestamping game object states is an easy and low-cost way to improve consistency. Timestamping allows for determining whether a game object's state vector corresponds to its configuration at a previous time or the current time. Code can assert or explicitly check the timestamp to ensure the proper state information is being obtained when querying the state of another game object during the update loop. Timestamping does not address the inconsistency of states during the update of a bucket. Next is applying concurrently to game object updates. First one is concurrent engine subsystems. Performance critical parts of a game engine benefit from parallel processing. A job system can be used to make engine subsystem execute concurrently. Ensuring thread safety involves using logs on all external cores into each subsystem.
Next is asynchronous program design. When a time-consuming operation is to be performed, we should avoid calling all blocking function. Instead, large or expensive jobs should be requested by calling a non-blocking function that sends the request to be executed by another thread, core, or processor, and then immediately returns control to the calling function. Next is job dependencies and degree of parallelism. To make the best use of parallel computing platform, we like to keep all cores busy at all times. In order to achieve full utilization of CPU resources in an explicitly parallel computer, we would like a DOP of our system to match or exceed the number of available cores. Next is parallelizing the game object model itself. Game object models are difficult to parallelize because game objects tend to be highly interdependent and are typically dependent on numerous engines and systems as well. This is some of the solutions that Naughty Dog uses: game object updates as jobs, locking during game object updates, object snapshot, handling inter-object mutation. Next is event and message passing. There are three. Games are inherently event-driven. Games are generally need a way to notify interested game objects. Different types of game objects will respond in different ways to an event. So that's all from me. Thank you for watching.